Recording in progress.
Hello to everybody, this is Andrea speaking. Now I managed to enter as a panelist.
Hello, Andrea.
Hello, Daniel.
Well, voy a hablar en español. Bueno, comenzamos este encuentro. Buenos días.
We are starting this meeting. Good morning. I have the pleasure to open the first open event of this Plus Neon edition 2021, organized by the National University of Mar del Plata. Is how should be the training or the education to join the Internet of Things revolution. The idea of this meeting is to have a conversation on how to adapt to this IoT revolution from the perspective of the students, the faculty, businessmen, and officers. The general program will start with a brief presentation introducing the project from Andrea Tonello, and then there will be a presentation on the results, the outcome of the meeting, of the survey that we conducted, and then a roundtable related to companies, and then a university roundtable, and finally the presentation, Cyber, Physical, and Internet of Things Systems, Educational and Skill Requirements by Dimitrios Serpanos from University of Patras in Greece. Before we start with the first presentation, let me remind you that you have to access the channel with the language of preference. Most of you speak Spanish, so you should click in interpretation in the bottom right and select the Spanish channel. In that way, you will hear all the presentations in Spanish, regardless of whether they are made in English or Spanish. And for the questions, there will be questions after the roundtables and the presentation by Professor Serpanos. those questions, we will be simplify the procedure regardless of whether you have received different instructions. But we will have the questions in the option in the platform, the Zoom platform, in the bottom, the center. There you will see you have the question and answer, so you can make the questions in the question and answer function that will be taken by the moderators at the end of each session. Now, finally, thank you for participating. And now let me introduce the first speaker, Andreas Toledo, who is a professor of communication in the Klagenfurt, Austria University. He's been technical director of Bell Labs in the US and general director of Bell Labs in Italy, where he was responsible for investigation, co-founder hardware and Bell Labs prizes and from the Society of Communication, and was convened by excellence chair of the University of President, the Society of Communication and AAA on communications and communication over electricity lines. He's the president of the Technical Committee of Communications of Smart Grids of the AAA, editor, associated editor of several journals. With you, Professor Andrea Tonello.
Andrea,
Yes,
okay.
I try
Yes.
to share my screen. Please let me know if you can see my screen and my slides.
Se ve perfectamente.
They see very well.
My name is Andrea Tonello, as Professor Carica just said. I'm the coordinator of the project NEON, and this is why I am happy today to introduce the project to you briefly. The talk will be in English with simultaneous translation, as far as I understand. Nevertheless, we prepare the slides in Spanish, hopefully to facilitate understanding. I would like to thank all participants for this event, and I would like to thank the organizers, in particular Professor Daniel Carica, for organizing this important open event, which stems out of the activities of the project NEON. The project NEON is a project in the framework of the Erasmus Plus K-Action 2 framework, capacity building in higher education, co-funded by the European Commission. It has duration 3 years, and it has the principal objective to reinforce the relations between high education institutions, let's say universities, and the social economic environment. We have 10 partners, in particular the University of Klagenfurt in Austria, where I am a professor, University Carlos III de Madrid in Spain, and then we have 3 universities in Argentina, Nacional de Córdoba, Nacional del Sur, Nacional de Mar del Plata, 2 universities in Uruguay, Universidad de la República e Universidad Católica del Uruguay, plus 3 companies, Incutex, Alacio, and Alenet. And then we have also, as associated partners, about 10 other companies that are following the project activities and supporting the project activities. Let's talk briefly about the objectives of the project NEON. We started from certain, let's say, point. Or let's say that the starting point was that we realized that IoT, Internet of Things, is a very innovative technology that has great impact to many aspects of our life and the processes that we are involved with. in many, many sectors that span energy, transportation, industry, agriculture, and so on, to realize this holistic view, which is called smart city. However, we also realized when we made the project proposal 2 years ago, more or less, that we realized that the understanding and the penetration of IoT solutions was basically limited. Therefore, the project objectives were defined. In particular, we defined the necessity to diversify education of human resources involved in the domain of IoT. And this involves both technical persons or technical employees, let's say, in companies, but also the academic domain, students and professors. So we want with this project to contribute to the modernization of university education and try also to raise awareness about IoT by reaching out, as we say, society at large. In particular, we have conceived specific actions to realize the objectives, and the main one is the realization of the so-called network of competence, or what we call network of competence on IoT, so that we can network both universities and companies and industry so that we can share competencies, experience, needs, and views. We also want to reinforce the infrastructure that allows to develop R&D projects in the domain of IoT through the formation of joint laboratories between universities and company. And we want to better the knowledge and, let's say, the education of students in this domain, and also teachers, so also professors, so that we can increase overall capacity. So to go a little bit in more detail, the network of competence can be seen as a container that will allow to develop and allows to develop content, in knowledge, develop solutions, and in the domain of IoT. So if we read this chart clockwise from the top, let's say, and then we move clockwise on the right side, we also want to develop a sustainable plan. Our objective is not to create a network just for 3 years, the duration of the project, but we want to keep the network alive after the project. We want to render the IoT a topic which is easily understood and more attractive for all stakeholders. We want to organize workshops and open events like the one of today. We want to develop 5 laboratories that will be established in 5 universities, but together with the industry. And we want to reinforce the study programs, in particular the ones in engineering, covering the IoT topics to a better extent. Then we want to improve knowledge of digital tools, e-learning methodologies, and so on. And also foster creativity and entrepreneurship. Students, probably this can be done, and this is the way we will be doing it, using also the instrument which is called hackathons, so that we can involve students in competitions where the entrepreneurship spirit or entrepreneurial spirit is well implemented. And also we want to offer opportunities for mobility so that students can be involved in internships in companies and can also visit the organizations that are participating to this project. So what we did so far in these 10 months that the project already ran was the development of a survey to understand the study programs better that was delivered to universities in Argentina and Uruguay. Survey was also developed and delivered and feedback, of course, collected to the industrial domain to understand the level of penetration of IoT technology and also knowledge of IoT technology. And today there will be specific presentations about this. There have been reach out activities in June, July to try to connect better and start understanding whether in this network of competence more participants can be included and are interested to be included. Another, let's call it the open event or virtual event, was organized in Mar del Plata. And now we are busy in developing, let's say, the details of the network of competence and also the 5 laboratories that will be physical locations with instrumentation and the material, let's say, that can be used to develop R&D projects in combination or, let's say, in cooperation between universities and companies. And of course, the event of today is another realized. So if I go to the conclusions in summary, what I can say is that NEON is about the creation of a network of competencies on IoT to reinforce cooperation between the industrial domain and the academic or research domain. It will develop competencies in the digital domain, new study programs, new methodologies, teaching methodologies to involve better students. And we also want to prepare what I would call continuous learning modules and education. So also people that already join the job environment, the working environment, might be interested to keep studying, let's say, or educating themselves. And overall, we want to increase capacities, innovation, creativity, so that we contribute, or at least we give our little contribution to the improvement of local economy. So with this, I have concluded this short presentation about the NEON project. You are quite welcome to follow our activities by looking at this website. And for anything more that you want to know, you are quite welcome to contact me or other project partners. So I wish a fruitful event today. Thanks a lot. Thank you. Daniel, I'm not sure whether you take again the lead here.
Thanks, Andrea.
And I'm not sure that there is time to take questions, so I'm not sure. So I leave the space.
Casti.
Hola Alejandro, aparentemente Daniel tiene un inconveniente.
Hi, Alejandro. Apparently, Daniel has a glitch. Maybe you can introduce the next talk by Mr. Cuso. Yes, I am going to enable him right away. Juan, you've got the floor. You're on. How do I share the screen, if I may? Give me a minute, Juan. I am going to enable you. Just a sec.
Tenés que aceptar, Juan, el privilegio de panelista.
Please accept, Juan, the panelist privilege. Sure thing.
Ya puedes compartir, ¿no?
Okay, how about the screen? Is it on? Yes. Good morning. I'm Juan Cuso from the National University of the South. I am involved in the NEON project, and I am going to give you an overview of the activity we've been involved in, trying to make a diagnosis of the industry needs and the academic community involvement on the Internet of Things, both in Uruguay and Argentina. This is an overview of the presentation. The goal is to give a summary of the introduction by Professor Tonello. Also would like to share the goals when designing the polls and surveys. And I would like to share some outcomes of our analysis of the industry survey. And also we analyzed the offer in academic curricula related to ICT in the involved and participating universities as well as other academic institutions. I would like to stress that this activity falls within the framework of the NEON project, but is a part of a more comprehensive report with the participation of the University of Clarenfurt, Maria Julia Fernandez Getino, from the Charles III University in Madrid. So I am going to share with you the results of the survey that are going to be useful as a diagnosis for the upcoming activities within the framework of the project. In a nutshell, these are the goals that were presented in very good detail, Professor Tonello. This is the competency network, and these 4 landmarks: the updating of the curricula, the production of educational material, the creation of 5 specific labs, and training activities, not only for the academic community, but also for the industry. So the idea of this survey was to make a diagnosis in order to make progress to achieve each of these landmarks. As regards the industry surveys, these are some of the guidelines for the goals. We wanted to have an idea about the future and the trends in Internet of Things within companies. We wanted to make a connection between the low level of IoT in Argentina, Uruguay, and the lack of skills in this field. We wanted to know the demand of training courses and other activities for training staff. We wanted to learn about the different domains where specific skills of IoT are required. We wanted to know the opinion of graduates about the practical knowledge, and wanted to have an idea of the cooperation level between the industry and the academic community in these specific fields. As regards the academic survey, we wanted to identify the available offer in terms of IoT courses that are already available. We wanted to identify potential courses that could be updated with IoT content. We wanted to analyze the creation of new courses in order to bridge the gaps in IoT training and eventually the creation of new labs with IoT infrastructure. So let's begin by analyzing the industry survey. This is the basic methodology. It was an online survey trying to emphasize the different IoT-specific domains, such as system embedding, data analytics, connectivity, security, and applications. We offered 27 questions grouped in 5 categories. This is a flowchart of the survey design. The design wasn't too evident at first. The 5 categories of questions are described on the screen. First of all, we wanted to know the respondents' profile, their potential interest in the Internet of Things, the specific interest in IoT, the specific skills that are considered required for IoT, and from the point of view of the employer, we wanted to know some aspects of their views on this topic. So I am going to give you an overview of this survey. As regards the outcomes, one finding is the horizontality of the IoT. It affects all the since even though we aimed at all levels within a company, the survey was responded by 150 to 160 respondents. That was our sample size. Most of respondents had a director of manager profile. That is to say, they are business oriented. The most used IoT systems within companies are the collection of sensor data. A large share of responses, 27%, state they do not use Internet of Things because lack of skills or lack of training and other reasons related. 50% of respondents have a positive view concerning the use of IoT for the growth of their activity and their company, and most of responses are positive, and people express their wish to embark in training courses and related activities. These are some other outcomes that we got from this survey. Most responses associated to the 7 domains that we had in mind are positive when they express the interest in getting training. A significant number of responses state that newly graduates do not have the proper training in IoT things. And in spite of the fact that most of the companies offer internships and opportunities for dissertation work, sorry, Juan, you still have 15 minutes left. We apologize. So I was in a hurry because I thought I had 1 minute left. I need 5 more minutes. Thank you. Okay, please go ahead. So as I was saying, in spite of the fact that most of the companies offer internships and dissertation opportunities for students, the goal is to increase this offer in the near future. And also, cooperation between the industry and the academia can be improved. There is room for improvement. As regards the key domains that we analyzed, and now being more specific, as regards the hardware domain, which may be the key domain here, the most important domain, system designs, a system on chip was the most relevant in terms of embedded systems and operating systems. For embedded systems, two options stand out: the general overview of embedded systems and operating systems, and the development of applications for embedded systems. In the communication networks and protocols domain, in the case of low consumption, large range wireless protocols, training in this domain was the most relevant. If we take into account the mobile informatic domain, the prevalent training is the multi-platform development. As regards distributed architecture, there is a prevailing need in IoT middleware. If we go to data analytics domain, there is a strong need in learning, automated learning, and neural networks. And as regards security, the prevailing need mentioned are algorithms and restricted device security protocols. These results are connected to the sample of respondents that actually took a part in our survey. So we are talking about a group with specific needs. So these are the conclusions. These are some of the conclusions in the industry survey.
Mainstreaming of Internet of Things, data collection as main activity in IoT that is collected from the survey in Argentinian and Uruguayan companies. It was the lack of insufficient skills and training was stressed. So there is a significant role for educational activities of this NEON project. A detailed analysis was conducted both of software and hardware applications as part of the survey, and the companies stressed the lack of practical knowledge in the domain of IoT of university graduates. And so it was concluded that there is role for improving cooperation between academia and industry. That is part of the objectives sought in this process. From the perspective of the academic survey, survey data collection, the idea was to collect information by institution rather than generating a generic survey, including the stakeholders and other entities, related organizations, and the information obtained on specific courses on IoT compatible with an improvement based on IoT content. The information, collected information, basically is listed here. Some differentiation by university, by country, between Uruguay and Argentina, the curriculum, number of years, name of the course, what year it is taught, duration, type of course, whether it's part of the core courses, mandatory, elective, modality. Usually they are all in person, and the teaching method, if it is lectures, practical cases, sessions with laboratory practice, tutorship, and a specific feature that is in the Argentine university system. We are only just beginning to define that, is considering the specific competencies per course, and then they are based on the assistance of precisely faculty at university level. In Europe, they already have this in place. 5 points were defined in terms of competencies. For example, C1, knowing the principles and problems of a certain field, in this case IoT, analyzing to identify, formulate, and solve field problems, to design an associated system, designing and conducting in associated investigation, or applying in practice the techniques and skills learned. In that respect, some reasons, most of the courses are in person, with the exceptions effective because of the pandemic. Basic courses, generally speaking, following this classification, follow the classical teaching techniques with lectures, practical cases and problems, and practical laboratory sessions, with the purposes that are listed here. In some conclusions in connection to academic survey, most curriculums contemplate basic sciences, basic technologies, applied technologies, and complementary courses, and then training by competencies would promote the inclusion of IoT content. There are almost no specific IoT courses, with the exception of the Catholic University of Uruguay, with the design, 2 courses on IoT design and embedded systems, IoT in agribusiness. And in spite of the lack of specific courses, there are numerous courses related to the topics of IoT, where it is possible to include content and improve the perspective in some of the domains of interest reflected in the industry survey. Well, that concludes my presentation. If we have time for questions. Thank you for your attention. Thank you, Juan Puzo. There is a question, very specific, but I will make it. Luciano Velázquez says very interesting results of the survey and asks how many agribusinesses were surveyed. I do not have the broken down the numbers between types of industries, because in that respect, we did not discriminate break down. We didn't break down by type of industry. What was we had a breakdown of who was answering the survey, had on the level of manager, or was technical staff, or at the level of decision making in the design or technical basis, technical level. We did not break down in the application specifically what type of industry each one will belong to. Yes, we have information available, and that will be made public. The final report on heterogeneity of the applications that work is being done on IoT in Argentina and Uruguay. Agribusiness is one of the important applications, but also logistics, services, energy. I would say there are several important applications where agribusiness is just one of them. Thank you.
Gracias por la respuesta, menciona Luciano.
Thank you for the answer.
Si no hay ninguna otra
If there are no further questions,
vamos a seguir adelante.
we'll move forward.
Digamos, de ser dinámicos y no perder demasiado
For the
tiempo.
sake of dynamism.
A continuación viene
Now,
vienen dos bloques muy
two
importantes.
important
Son las
sections,
mesas redondas,
like
donde
round tables,
los panelistas
where the panelists
van a dar su punto de
will
vista o su experiencia,
present their
su
perspective, their experience
sobre
on
la capacitación o la formación
the training
en
or
lo que es IoT. En particular, empecemos
on
con
IoT.
el bloque de
They will start
empresarios.
with
De
business
alguna manera nos van a compartir un poco qué es lo que están haciendo
that will share what they are doing
empresa y
in their companies
qué
and
aspectos relevantes
what
consideran
relevant aspects they consider,
sea en algún aspecto
some
o
specific
algún
aspects
requerimientos
or some
en cuanto a la capacitación
requirements
humanos
of the
en
training
el área de IoT.
of human resources on IoT.
El bloque está esta mesa redonda
This round table
integrado por
will be composed of
Bernardo Martínez Sáez,
Bernardo Martínez Sáez from Day 3 from Mar del Plata,
Pablo Manzano.
Pablo Manzano,
Pablo Manzano, estás en EICON,
who is
¿cierto?
in Bahía Blanca,
No, en Incutex.
Incutec,
Incutex en Córdoba. Bien, bien.
in Córdoba.
Después lo tenemos a Marcos
And then
Pascualín. Marcos,
Marcos,
te tengo. ¿Estás como panelista en este momento?
panelist right now, or attendant, piece of the panelist.
Marcos,
From
entonces,
Marcos,
Pascualín,
Pascualín
de la empresa
represents the company Econ,
Felipe Esteves,
Felipe Esteves
de Uruguay,
from Uruguay,
de la empresa,
from
recordame la empresa Felipe,
BQN, Alacio.
BQN Alacio.
BQN,
Y
BQN,
finalmente Agustín de
and
Recibus.
Agustín from Brazil.
Agustín, tu empresa es
Your company?
Netra.
perfecto, Netra.
Sí.
Bien. Bueno, en primer lugar,
So first of all,
los mencionados y luego
we'll have
va a haber
each member will
una ronda de
present,
preguntas
and then we will have
que,
questions. So
vamos a responder en conjunto todas las
then we
preguntas.
will answer the questions.
Bernardo
Bernardo
de la empresa
Martínez Sáez
va a ser el
from
primero,
the
primero
3 will be the
presentar.
first speaker,
Adelante, Bernardo.
Day 3. To present here and collaborating for the ecosystem of IoT to evolve. I will make this presentation. I am Bernardo, CEO, co-founder of D3. We do Internet of Things products, supporting two services, safe, security, and energy. In this presentation, Daniel asked me to talk about how to educate to enter the revolution of IoT. My presentation is based on a subjective opinion based on who I am and my own experience. I am an industrial engineer, an entrepreneur. I work in Latin America. And based on that, that will be the perspective of my presentation. The opinion, what we should strengthen. In our case, we started trying to solve a problem. And this is something that we could take into consideration in the programs, university programs, where sometimes we do a lot of work on basic research and not directly on application. And that many times graduates cannot feel immediately. We have to work on that.
So based on that, we looked for a common problem for these two services, a poor structure and poor lack of electricity, and we spot an opportunity for these type of companies. They use obsolete equipment or equipment that was designed to be installed in developed countries with a higher level of connectivity. So we developed a mesh solution, we developed the module, we interacted with a microchip team that was dedicated to us in Spain. Something I want to make clear: in the electronics world, in the real world technology, this is something that we have to take into account and something we have to stress in our curriculum. I have counselors, advisors, students, and people. So we have this module and the platform that manages communication. After that technology was developed, we developed the products that were actually needed. First, we created a city mesh, an alarm system, something interesting in the real world. In Latin America, you have to be aware of some limitations. We didn't have enough funding to reach the end user. So this is something that we have to take into account during training. After this product, we created AMIAR, that is a smart meter specifically developed for developing countries, taking into account some needs that are specific to our region. We have customers in 12 countries in Latin America with over 20,000 units installed. Most units are in Argentina. We have a holding company registered in the US, and our manufacturing plant is in China. From our perspective, from my subjective point of view, what I try to do is to offer my opinion on how to train people to work in technology. Of course, I'm not cognizant in many aspects, but this is what I think. In time, we built this company, and as we went along, we had to learn new methodologies. Well, new for us, they are 15 or 20 years old, but until we didn't need them, we never knew of them. task managers, very powerful CRMs. This is something I always want to stress. And you are not alone. This is something you had to mention in college. This is something that you have to strengthen, because this is problematic in Argentina. Argentinian academia is very isolated from the rest of the sectors and the rest of the areas, and this is something that we could improve. This is an example, an association, a partnership with technology companies, the agency, a government agency that provided funding. So from the university, we had to understand all these topics, and from day one, if we had started these from day one, this cooperation, it would have been much better. So, based on my experience, I have to tell you that university educates us or trains us to be very good employees, but university doesn't prepare us to be an entrepreneur. And university doesn't encourage entrepreneurship and has nothing to do with venture capital or risk capital. And this is essential if we actually want to develop IoT in Argentina. This is horizontal to all sectors. So this is something we should encourage. So this is my humble opinion. I'm open to questions, and I didn't want to, I apologize if I was too brief. Thank you very much, Bernardo. Now we are going to move on to our next presentation by Ingeniero Pascualin from ACON Bahía Blanca. Okay, please give me a sec to set things up. Is my screen okay? Yes, your screen is perfect. Thank you. I'm Marcos Pascualin. I'm engineer developer for ACON Limited in Bahía Blanca. We work on smart cities. Most of this is closely related to Internet of Things, even though we use another tools, but we've been using tools that you may think are suboptimal. So in this time, we've been working in these topics. We've been working in logistics, satellite tracking. Also, we work with payment in public transportation, metered parking systems, parking sensors. So as developers, we had to train in quite a number of different technologies. Even though these technologies are horizontal to all these sectors or domains, these technologies, in my opinion, have one thing in common. They are modular. That is to say, you can take any one of these and you can make incremental improvements. You can build on top of these. So we had to train in soft technologies, in hardware. So the thing is that it's not as hard to catch up and keep abreast with these technologies. You can easily adapt these. You can build upon these to improve your products. But there is something I would like to pinpoint. You see many labels, cryptography, RFID, DSP. Even though these are very strong, they have this thing in common. they are incremental. But there is a weak link in our training. There is a weak spot. This is a biased opinion. Of course, I share this with Bernardo when it comes to developers and training. Bernardo and I have many things in common. We are in Latin America. We are in the business sector. And the context in our case is no minor issue. And there is a lack of training and a lack of education in IoT. And this lack of training makes it harder to make certain decisions. So our products have embedded many up-to-date technologies. For instance, we have up-to-date sensors, but they coexist with obsolete communication platforms because it's very hard to assume the risk of getting new technologies because we don't have the trained staff, because we are not trained to make decisions in these areas. So as a private company, it's very hard to us to venture into these risks, into these sectors, because the risk of a poor decision is too high. And very high because the people we have is not properly trained. So if we have experts in IoT, it's because they are self-made professionals, because they are interested in these topics, because they conduct their own research, they participate in contests that happen abroad. So this would be the MO. In Argentina in 2020, the Argentine Chamber of Internet, yes, the Argentine Chamber of Internet created the IoT Chamber. That was a driving force, but we need the academic community to keep up with us, to meet unmet needs in the market. So it is complex for us. This migration is complex for us because we have to bridge a gap in technology. And why is this? Well, changing a communication technology is not incremental. This is central, critical for an IoT device. If the design of a device is going to change 180 degrees if we change the communication technology, because its capabilities are going to change. I cannot migrate between communication technologies without changing the design. The right approach would be to dominate one communication technology and make a design based on that knowledge. And in this way, you would have an optimally designed device. But we have an assortment of IoTs. We have many alternatives available. We have a wide range of things to choose from. And like I said, the cost of a mistake is too high. A Latin American-based company, an Argentinian-based company cannot afford to make mistakes because the cost is too high. So this is a very, very tough decision at the for the high management. Almost 30% of IoT projects in private companies in Argentina, they fail in the proof of concept stage. They fail that proof of concept. They fail because They don't see the convenience, or they don't have the know-how to face this project in the right way. So we have many metrics. We have data sheets and indices, indicators that you have at your disposal, but we don't have the expertise. And I'm speaking community-wise. In Argentina, we don't have a referent. We don't have a person, an institution that you can go to with your problem. Like Bernardo said, I have this problem. How do I solve it? We don't have anybody to turn to. What would be the IoT technology that would help me reach my goal? I may be having a conversation with another enthusiast, but we lack know-how in this area, sound know-how. Our metrics are impersonal. The information applies to a context that is foreign to us. This information applies to other geographical areas that have different communication infrastructures. So we cannot really be involved in this because we don't have the means. Thus, these, in my opinion, makes it very complicated to make a sound decision. So what we need, in my opinion, are these 3 points, these bullet points. We need hands-on training. We need people that can check the devices, analyze them, use them, set them up, the consumption, the range, the physical obstacles. And this has to do with hardware availability. For us, it's really expensive to have testing software and hardware, and also the customs obstacles. And something very important, we need expert advice. We need people trained and people experienced in certain problems. So thank you very much. And I was wrapping up my presentation. So thank you. I'm available for questions.
Bueno, muchas gracias. Muchas gracias
Thank you very much for your time. And now we will give the floor to Pablo Manzano.
Pablo Manzano forma parte de
He's the part in Incutex, Córdoba, Argentina.
Hola,
Buenos días.
buenos días. Yo soy gestor de fondos en Incutex.
I am fund manager in Incutex.
Ahí venimos a cubrir ese espacio.
We cover this.
A captar
Mm,
a todos los emprendedores.
We try to reach technological entrepreneurs
Para fomentar,
to promote in entrepreneurship. Our purpose is to transform the relationship between investors, developers, and academia to promote regional economic development. We are located in Córdoba, but we receive entrepreneurs from all over the country. We consider that Incutex is part of an ecosystem, so we have different aspects. We cover investors that not only with money, it's a concept we work with, but it's smart money, with which the entrepreneur finds not only money, but also a multidisciplinary team that accompanies and helps reduce the risk of the investor trying to move that product forward, as we have invested in all the verticals. mainstreamed by technology, e-commerce, retail, health care, education. We cover all sectors. And we also have close relationship with corporations through this knowledge and the new technologies. As we stated, we need knowledge and support to develop. From Incutex, we can accompany entrepreneurs with technologies. We work with open innovation to incorporate new technologies, and sometimes they don't know how to do it. So through Incutex, they find a way to do a survey, to approach solutions and proposals and reduce costs. We are also related to the academia. We have invested in over 25 projects. We have connections at all government levels, so we can co-invest. For each dollar we invest in a project, the government co-invests with us, so the entrepreneur may have leverage to fund and accompany the growth of the enterprise. We are closely connected with the academia, receiving well-trained human resources. We can contribute with these tools and methodologies that universities do not cover, but students need to not only work as faculty or investigators, but so that they can set up their own businesses. So we work with National University of Córdoba, Siglo XXI. We provide distance education through platforms. We have relationship with schools specialized in artificial intelligence, with development of the Internet of Things, and other organizations with soft skills that complement the development of entrepreneurs. As I said, many companies trust us to accompany them in their open innovation. Many of the products have had a close relationship or use the IoT technology. Many have passed the proof of concept. Some have installed them, some have not. But we have been able to approach projects of IoT to corporations in Argentina. We have a multidisciplinary team to accompany, other than money, but a team that helps them to develop as entrepreneurs. We cover different aspects, team development, human resources, work methodology, a multidisciplinary team to develop these skills and transform startups into larger companies. Along with the National University, we conducted a survey and found out that the vast majority has not developed, has not used IoT. 1/2 of them have no information or do not know the benefits of this technology. And those that have used it have stated that they need knowledge and skills, technical skills for the development of interface, management and control of microcontrollers and microprocessors, the knowledge of embedded software, connectivity, network connectivity, different software, multi-platform, and once the data is collected, so that they can be translated into valuable information. So, well, this is my presentation, just to tell you that there is a space for these entrepreneurs to use this IoT technology, and so that they can be a company and complementing their knowledge with development, so that they can reach
Muchas
higher
gracias,
levels.
Como todas las
Thank you.
presentaciones muy interesantes.
Very
Así que
interesting.
vamos a dar lugar
So
a
we'll
Felipe
now
Esteves
move
de
into
las
Fabián
Flores
Esteves
de Video,
from
Uruguay.
Alacio, Montevideo.
Felipe Esteves, perdón.
Felipe Esteves.
Buenos días.
Good morning.
Bien, ¿se está viendo ahí? Sí.
Se ve perfectamente.
Bien. Como mencionaban,
As I said, I am Felipe Esteves. I work in BQN in the role in investigation and development.
para un poquito de contexto de
Just to give you some context of the company,
BQN es una empresa que
it was founded in 2003 in Montevideo, Uruguay,
y nos enfocamos en
and we focus in the development of hardware and software, tailored, individualized hardware and software. The areas we have had at Bankinet for games, and we have had iteration of our own development, and the other is Baquiano, that originally came up with the development of readers for cattle caravans, when in Uruguay it was made mandatory, and we became more strong in agribusiness. Our first development in IoT was precisely a solution for agribusiness. There is a heat detector with LoRa connectivity, where each animal has a device with readers and other sensors to detect the heat of the animal and communicate with a central antenna, and then goes to the internet to a server. Now, the characteristics of this device is typical of a IoT system: transmission every hour, stores 18 hours of data, maximum distance from node to tower 11.4 kilometers, which is fundamental in the country, particularly in this region, because we do extensive breeding, very low consumption, 3 microamperes, a challenge for us, but with the most amperes per hour last 3, 4, 5 years, acceptable. This is a product development that we have used for IoT, and we reached the final solution. And then we also have telemetry and VIoT using and VIoT. We are actively working on this product. Characteristics are a bit different. Transmissions once a day. Data collection is almost continuous, because this device is connected to reader and reports to a server. Basically, all the time collected data. The purpose is to have 5 to 10 years of useful life. We are using Quectel models that have good modules. So these are developments we have had so far. So we are not 100% IoT company, but we have explored in IoT for certain products, and partly why we are not only IoT only. Well, we have a few challenges, as has been described earlier. First, when we want to do an IoT solution, what technology to use? We do not have a technical training in the existing technologies, advantages. So at the time when we want to approach a new project, first we have to do a research on these points. What do we choose? How the technology work? What requirements? What consumption can I obtain? And then also, as we said, it's difficult. It's a challenge to select. And once you have selected, sometimes you encounter problems when you have been working with the technology for some time. So we need further knowledge on technology. Another challenge, as I said, we are not used to working with so low consumption. Therefore, we didn't have equipment to measure whether we really were in those ranges. Also to run tests, we didn't have that type of equipment or experience. And then the other challenges, once you choose the technology, once you landed, what products to use, what modules the technology provides, and others. It's a world in which each technology is unique. We have no experience.
How we propose to improve these aspects so that we can make our own informed decisions. We can have our professionals to be more informed than us. First of all, the training in shared concepts that are common to different IoT technologies. Also, we need examples with real applications, with real life applications in production, because we discuss about different characteristics of these technologies, but we need them in real life. And in order to be able to make an informed decision when choosing a technology. And also, related to this, we need examples, because sometimes the examples in IoT talks and courses, we need real life examples. This technology is in use in this company, in that country. So that is what we need, something that already passed the proof of concept and it is already in production. This is going to help us strengthen all the concepts that we already have. And we need to implement and to have practical knowledge in at least one IoT technology, from the devices to the network. That is to say, we have to choose the modules, design the device, implement the network, implement the whole solution. This is rather ambitious to encompass in a single course, but it's very useful. And when the graduate student is absorbed by the industry, he or she should already have experience in a given technology. Maybe that's not the technology he or she is going to work on, but at least he has a 180-degree view of the whole process, an end-to-end view. So that is my subjective opinion. That opinion is based on my own experience, but with If we join the experience of all people, we are going to get an interesting corpus.
Tengo entendido que en un ratito hay espacio para preguntas.
So I know there is a Q&A session later on. Yes, Felipe, please stay with us. Now we are moving on to our next presentation, a colleague from Montevideo, Uruguay, from the ENET company, Agustín de Regibus, is going to be our speaker. Thank you very much. Thanks for the opportunity of speaking to you. Before our specific topic, what we do in Netra, I'm CEO and I'm the technology director in the company. I'm an electronic engineer, and now I am more business oriented, but I'm closely related to engineering. So what is Netra? We are a company that specializes in the development and deployment and IoT technology for telemetry and distributed control. I'm based in Uruguay, but we have offices in Chile and Argentina as well. And for the products we have over 1,000 devices implemented. We've been working in IoT for over 10 years now. And like I said, we have over 1,000 monitoring points deployed. So what is it that we do? We offer flexible solutions that can be adapted to the customer needs. We develop our own hardware, we integrate different platforms, we integrate different sensors with a very powerful software platform in the network, and we can offer real-time information of all our products. So this is something that is related to the training. In Uruguay, we cannot afford the luxury of restricting ourselves to very limited verticals. We have to be very general. We have to take a look at this from different angles because this is our way of surviving. So we work in the energy sector with IoT, fleet management, agricultural technologies, weather, climate platforms. So how is it that we do this? Our strength was software development. So we have a couple of products such as gateways to integrate different sensors and actuators. We have different user interfaces to link this information with the cloud. And we have a cloud software platform. This is one of our hardware devices and our platform that we created, Telemetry Plus. And let me give you some real life examples of what we do. We monitor the water distribution network in Montevideo. We monitor lighting of advertising billboards. We have technology to know in real time the status of irrigation systems. We have a product that is useful for measuring the level of groundwater, and we are working with the Waterworks company because there is a legal requirement for each user to know the level of water consumed. So we are helping to measure that. At this point, the SCADA systems are the most widely implemented for this, and the cloud concept, the real-time information, is not very prevalent yet. But we are working on developing hardware, software, and the integration of different sensors. This is what NETRA does in a nutshell. This is our mission, and this is to give you an idea of what we do in real life. So, what is it that we can improve? What can we do together with the academic community in order to train our students to succeed in IoT? Well, on the one hand, this subject, IoT, is a really broad topic. We could be talking about telemedicine or agricultural topics, but we have some common topics such as data management. And the situation in our country, in Uruguay, a startup company cannot afford to create a multidisciplinary team of people with experts in many fields. So I think something interesting would be to have people that is trained in two things. We need people that knows very little in many different areas. This is something that would be very useful. Sometimes people that are experts in computer science, sometimes they lack knowledge about real life. And the same applies to many experts in electronics, in design. So sometimes it's very difficult to make a connection between these professionals because they don't speak the same language. So a startup company cannot afford a large group of experts with different roles. So we need people that is multitasking, people that are able to cover many fields, that have the minimum amount of knowledge that is necessary. So maybe we can organize IoT workshops where students can interact in order to create a well-rounded product. Because actually this is what happens when you enter real life. Academic projects concentrate on a specific topic, and there is little cross information between different areas. But in real life, there is a lot of crossing, there is a lot of interaction. But we are talking about electronics, software, hardware, and all this is really intertwined, and we need people to understand that intertwining. And if we are going to train entrepreneurs, we need people that knows a little bit about everything, people that needs about business plans, investments, how to approach an investor. So that would be it. If I had to choose one thing, I would try to train people in these disciplines that have to do with IoT, so that people can leave university with experience in their own topics, and that also have knowledge and experience in dealing with professionals from different fields. So that is my subjective opinion. And of course, this is context dependent, depends on the country. So thank you very much for your attention.
Gracias, Agustín.
Thank you, Agustín.
¿Me están escuchando bien, no?
So how's the audio, everybody?
Perfecto.
Sí, sí.
Very good.
Ahora vamos ya pasar al bloque de preguntas.
Maybe we can start our Q&A session at this point.
Esta mesa redonda, con participación de los
Q&A,
con
questions and answers about these panels. We have representatives from 5 companies from Argentina and Uruguay.
traten de formular las
Let me remind you, please
preguntas y respuestas.
send your questions through the Q&A function. I have seen a question in the chat window.
Alejandro,
Maybe Alejandro, you can read the
Sí,
question.
cómo no, Daniel.
Yes, of course.
Guillermo Riva de Insus hace la
Guillermo
pregunta, ¿qué
Riva
protocolo de comunicación
asked,
utilizan?
what mesh communication protocol do you use? Guillermo,
Orientada.
can you please tell us, this question is addressed to who,
supongo
please?
que a Bernardo, ¿no?
Bernardo, I would say.
Sí, debe ser Bernardo.
Yes, I'm sure this question is addressed to Bernardo.
Hola, sí, es protocolo propietario.
Well, we use a proprietary protocol.
La frecuencia de 902.
The frequency is 902 to 911 megahertz that was mentioned by Marcos. 802.11. I don't remember the precise number. With the Contiki operating system. Yes, Marcos. Yes, you said it correctly. 802.11.4. This is a proprietary protocol, and I think that with that the question is answered.
Bien.
Thank you, Bernardo.
Paso a la siguiente de Juan
And
Emilio
now the
Guzmán
next
José,
question,
dice,
Juan
"Buenos días,
Emilio
Daniel.
Guzalmen José.
Desde Argentina.
Good morning,
Más
mostly
allá de
for
las
Argentina.
indiscutibles
Beyond the
diferencias
training,
entre
education
los
that is
países,
necessary,
¿cómo
my
accede
question is, how do you access technology to
Estamos
develop your
hablando de la
product?
fase inicial
Talking about the
de desarrollo
initial
aún no
phase
está
in which the
formada
company is
y
still not
que no se cuenta con el capital para
formed and
principalmente
doesn't have the capital to
pensando en
invest,
la poca
mainly
disponibilidad de
thinking of the
Argentina,
lack, insufficient availability in Argentina, how complicated it is to buy abroad with the resulting or consequent imports.
Entiendo que la pregunta,
I understand the question is for mostly to the panel from Argentina. Yeah, if we had the answer to that, well, it would be very good. There are certain companies that are ready to make hardware loans. We could do that some time ago. It's in an agreement. They loan a test module, considering that you may develop a product that is worth enough for them to find it convenient. Their feedback is that, of course, for that, you have to have a very good business plan and show to these companies that you really are serious and want to make a feasible product, viable product. In our case, we have capacity to complement with many companies that have subsidiaries in Argentina. It's more than we think. We are not alone. There are many things to do there. It is something that no one goes out to life knowing, but it is a matter of contacting, discussing, and seeing how far you can go. It's not easy, but well, yeah, there are options.
Muchas gracias.
Thank you. I wish to add my own experience precisely our core is based on transfer of technology that Microchip did for having used the module that we use those controllers that we bought in the US. With that, we started with that. We had cities in our 1,000 equipment in one city that stopped working. Many things that happen to them, ending up with commercial in payments, the transfer of technology with 15 engineers that are dedicated. There is a story, but it can be done. It's not that it's just buying and testing with the manual. If you establish contact with the channel exist. There are no more questions. One from Leonardo. There were others in the chat. Well, I have two questions here. Leonardo Steinfeld Volpe. A question for Bernardo Marcos. Why did you opt for a proprietary protocol when there are open options based on IETF that is available in Contiki? Well, I can tell you now about us. In our case, in the past, we had used open protocols. We could not achieve stability. So although we are in the Contiki community, we collaborate and we receive collaboration in our development. What is true and actual is that we ended up in the proprietary protocol for this particular reason. Lautaro. Marcos? Well, I agree with what Bernardo said. The reason to go from an existing protocol to a proprietary one is a matter of stability. When someone develops a protocol, you develop with a global objective so that many people know it. But when you need a specific application, you need to use, otherwise you wouldn't be using an embedded. Embedded comes because you need an optimum implementation. So that's why. It doesn't mean that they are not an excellent starting point. Lautaro Livio, respect to the final user interface client. What type of platform do you use? Software? Do you build it from scratch? Or do you use external companies that offer the service? In my case, very briefly, it depends on what is worth. Sometimes it is small, can be developed in-house and permits to have better control, but sometimes you cannot develop. So the most, you don't have to fear that, is outsourcing. We pay to a third party to develop a platform. So to me, that is very important. The same for us. The experience about UX we do not have. So app mobiles are outsourced to the front end from the design to the code, and the services, backend services, yes, we do that. Sometimes we do factoring and then our own team does the final work. Felipe, Pablo, or Agustín, if they want to participate, of course, you can just jump in. And about that question, we started a pathway of our own development. Our focus has always been in electronics. So we have to understand what is your strength and be able to integrate of what you do not know what is outside and integrate. I said IoT has many specialties. You cannot be an expert in everything. So if you want to do projects, comprise a broad spectrum, like in our case, software is a partnership that we have with a company that develops an IoT platform, and we work with them.
Bien, paso a la siguiente. Perdón, Felipe. Felipe.
No, no iba a comentar, me ha parecido a Agustín, nosotros también nos
The
enfocamos en la parte
same as what, similar to what Agustin said,
y el firmware, digamos.
we are developed on
En particular
electronics,
el
particularly
estamos usando
in
FreeRTOS,
R&D,
pero de nuevo, todo solución a medida, digamos.
but it's
Y
all
si bien tenemos un equipo
tailor-made
de
solutions.
desarrollo de software,
And we have a software development team. We have not worked
la parte de software de esta
in
solución.
software for these solutions.
Bien, gracias.
En esta última, digamos, que todavía está en desarrollo la parte
So for
de
these development is regarding electronics.
Bien. Paso a la siguiente, Daniel.
Dale.
Tengo una pregunta de Brian Lorenzo, quien dice:
I have a
rescato
question
de
from
la
Brian
presentación
Lorenzo,
del
and I
doctor
take
Couso
from
el dato de la casi
Dr.
inexistencia de
Couso
cursos
the
específicos en IoT.
non-existence of
Finalmente,
specific
uniendo un
courses
poco
in
con lo que comentó
IoT,
el ingeniero
a
Pascualín
link
sobre
into
el
what
estudio
Dr.
hobbyista como posible
Pascualin
extensión
said about
en materia de
the
IoT,
hobby
la pregunta
approach
sería,
as
si ustedes
starting
fueran
point. The question
estudiantes
is,
de
if
carreras
you were a
electrificadas
student of the electricity programs and you were seeking to enter these, door would you not add? What is the starting point? I would say is an IoT profile can be very broad as a concept. So you could do IoT without knowing hardware. You can develop a software platform and link into what was said before, the investment required, where to get the funds. It depends on the what application. If you do IoT, I program with my friends and I develop software. And it's not wrong to say that you are doing IoT. You don't need a physical electronic equipment. Now, if you go on that orientation, the simplest is to discover the world and started to do things. Go into the hobby aspect. The importance of creating teams. It is so broad that you need different profiles. To create a team, establish a team, an interdisciplinary team, someone who knows about business development to try whether it'll be scalable, you could, and to the most technical aspects, how to create value based on data or all the data collected. I recommend to choose a vertical, specializing in creating teams. That will make sure that you can get further. An idea about the results and the way how we defined our survey. Precisely, I highlight something that in the experience of Professor Tonello in applications of networks in general, not only IoT. There are what we call precisely domains of interest that have to do with very diverse things, such as incentives, connectivity, system integration, security, etc. In the survey, there is a an indication that there is definite numbers of domain of interest that cover a large range of applications. That's where we try to make emphasis in the training, in education. For us, we need to limit somehow precisely how to project that knowledge in specific courses or not. And it is important, particularly having interaction with you, with the industry, to limit the number of domains of interest. But I agree with the vision in general that IoT is not a specific training, but it is generic.
Bien. Daniel, tengo una última pregunta.
I have a final question from Marcos Funes, who says it would be interesting to compare Argentine experience with that of the panelists from Uruguay to establish the difference, how to start up a company, entrepreneurship.
Claro, acá me amplía y me dice comparar la cuestión de acceso a
Comparing access to technology imports, have you found obstacles for starting the development of access to funds, financing? I understand Uruguay has a benefit that has to do with imports of equipment in Argentina because of macroeconomic conditions and permits to import also there are some areas where to settle that has tax benefits. Many Argentines are establishing holdings in Uruguay to operate from there in the rest of Latin America if they do not go to the US. This is what I am seeing in the ecosystem of entrepreneurs in general. When facing the difficulties, entrepreneurs do not stay quiet, but they look for the way out to move forward. Uruguay also has accompany entrepreneurs with funds, so in this respect, there's not so much of a difference, but it's a matter of macroeconomic policies or exchange, imports, exports, and fiscal benefits. And many times they decide to establish the company in Uruguay to operate for the rest of Latin America.
Okay, we've run out of time for Q&A session. Thank you. Okay. Actually, we had scheduled a few minutes between blocks. Now, the academic block should start. But since we have a few spare minutes, we can answer an extra question that was submitted in the chat. So maybe we can answer it. I am going to show you my ignorance. I wonder if proprietary protocols do not conspire against the generalized expansion of the network and or interconnectivity. Well, in short, that depends on the layers. If you are talking about building-based protocols for IT, yes, you are going to have a collision. If you have protocols for higher layers, there shouldn't be any criticality. So for specific applications, it may not be a restriction. So that would be in a nutshell. I agree with Marcos, yes. Because of the stability and the efficacy we need in the case of Uruguay for battery consumption, for instance, there are many things to consider. The standard open protocols are not 100% efficient, but if we talk about layers like Marcos mentioned, we would be fine.
Agradecemos entonces a los panelistas. La verdad que estuvo.
I want to thank the panelists. The presentations were really interesting. Bernardo, Marcos, Felipe, Pablo, and Agustin. And we wrap up this roundtable, and this roundtable, the university roundtable. We are joined by Juan Fino Quieto of the National University of Córdoba, Raúl Rivera, Alejandro Urici from the National University of Mar del Plata,
La gente de la Universidad
will be
Católica.
joined by people from the Catholic University of Uruguay, Leonardo Steinfeld. Leonardo, are you there? I don't know if I gave you the privileges. And also we have people from the Republic University, Alfredo Arnaud. Let me check this. I am going to give you panelist privileges. Am I missing anybody? Well, Alfredo is from the Catholic University, actually. Thank you. I stand corrected. Alfredo and Leo, are you there?
No aparecen en panelistas, Daniel.
No aparecen en panelistas.
They are not in the panelist list.
No los veo en participantes tampoco. Alfredo.
And Alfredo is not a participant either. Jorge Fino Quieto is asking to be made panelist. Okay, Jorge, there you go. Jorge is already a panelist. Leo is also a participant. So Leo, let me make you a panelist. And Alfredo. Alfredo, we lost you. I think I saw you. So let's begin. And Alfredo is going to join us during the event. So, Raúl Rivera, Jorge Castiñera, Alejandro Uriz from the National University of Mar del Plata. Thank you, Daniel. Good morning, everybody. A real pleasure to share with you this event, to talk to you about our educational offer here in the University of Mar del Plata. I'm sharing my screen now. Yes, Raúl, you're fine.
Bueno, la idea de dos cursos que vamos a comentarles.
So we would like to talk to you about two courses here at the University of Mar del Plata. The first is an introduction to IoT, a hands-on IoT course about the experimental development of IoT technologies. The idea is to practice, hands-on experience. This is a remote education course that we are proposing. The goals are to acquire knowledge and practical experience on technology, IoT technologies and applications. We want to develop projects in automation, remote control, domotics, networks, and we want to analyze new integration tools to identify opportunities and facilitate the implementation of IoT technologies. It's going to be a remote learning course with a high degree of practical activities, building and interconnecting devices, configuration, programming. We want to practice the different stages and components of IoT devices. This is a hands-on training in IoT technologies. The idea is to offer an experimental introduction to IoT technologies to understand how IoT devices work, the connection and application of digital analog sensors and actuators, to develop firmware for IoT devices and software for web servers, also to learn and use development tools. And also we want to work on the access to these data. As regards IoT architecture, we want to explore the connection of the physical world with the web. We want to learn about how to manage and visualize information. Also, we want to learn about the management and smart use of data. What kind of management and smart use of data can we use? And finally, applications. How to handle and visualize the information by means of APIs and web services. As regards the IoT fundamentals, well, we have to acquire data, connect, store, analyze, display, actuate, and predict. And these are the requirements. This would be the first subject of our course, would be an introduction. We would present the technology to start working on it. We will be working with distributed technology, object interaction, scalable architecture, and that would be the introduction. Next, protocols. These are the protocols we would be offering. MQTT, in particular, messages, publication, presentation of the protocol, and then we would offer an experience with it. For instance, it would be the access to a laboratory through MQTT. We would be working with smart cities or an industrial process. The idea would be for the student to test on that process what we've seen before. So this is the hardware we would be using: Arduino, Raspberry Pi, and Adafruit. We would offer information on actuators, sensors, and peripheral devices, connectivity, gateways, Raspberry. We would be working with Node-RED and Python, the IoT platforms. What do they offer? What services do they offer? Amazon, Google, and we would be putting up a virtual server in the cloud, and what stages you need to cover in order to reach it. And finally, user interfaces. We would be working with Node-RED. We would be looking at graphical interfaces, which are really easy to implement, the dashboard, or also we would be using Android IoT panels. Now, I would like to give the floor to Jorge Castiñeira, who's going to present another course that we plan to offer here in the University of Mar del Plata. Good morning, guys. How are you? This course that we are proposing is aimed at the microwave and millimeter wave design for IoT, the communication devices behind IoT. For those of you who don't know this course, the goal is to change the paradigm in device design, sorry. So we would be looking at this from distributed design, because at such high frequencies, the classical design of circuits that are based on concentrated parameters, this doesn't work. So we have to change the paradigm. So how would we design a device? What's in it? If we want to add capacity, for instance, so we want to interpret the physical features of the hardware that will enable us to choose one technology over the other. So we are going to use one device with everything in it, but the question is, what do you have in it? We want to conduct this course focusing on radio frequency, microwaves, or millimeter waves. And this is something that we are going to face. Today we have a computer with a 3 gigahertz clock, and this is what we have. We have to adapt to that specification. This is a block diagram of a LoRa. So how do you work with a loud noise amplifier? How do you adapt the antenna? And we will have another course for antennas. And eventually, if need be, we may even design a device to accommodate a certain given need that we would propose. And we are going to use simulations with dedicated software, and we are going to design an antenna for a given application. And these are the practical deployments of the system. So the idea is to go from the simulation to building and to make sure that we design properly the device. So this is the goal of this second course that complements the introductory course to IoT. So thank you so much for your attention, and we are open to questions. Thank you, Raúl and Jorge, Alejandro. And the questions will be left for the end of the round table like we did before. And now we are going to give the floor, hand over to Alfredo Arnaud. Alfredo, can you please share your screen, if you may? Alfredo, can you hear us? Hi, can you hear me? Good morning.
Ahí están viendo mi pantalla, ¿no?
Sí.
Sí, perfecto, Alfredo. Bueno, Alfredo nos acompaña de la Universidad Católica de Uruguay.
Alfredo from the Catholic University of Uruguay.
Bien. Bueno, yo les quería contar un poquito.
I would like to present on courses and resources in the Catholic University through the NEON project. Just to discuss the courses we will teach and the resources we expect to implement. Now, first, the Catholic University is a small university, 9,000 students in all. And there you can see the main programs offered by the university. Electronics, engineering, and also attention is being paid in information technology, telecommunications, power electric systems, again, and in industrial engineering, for all the industry. There's one of food engineering. There is a project of opening one for agriculture. There are many programs that in a way are related to IoT as it grows, with the importance from all perspectives. Now, let's not limit it to engineering. There is healthcare that is also related. IoT, agribusiness, or there's a list of courses that we have sort of creating or reformulating. First, there will be a couple of new courses and others with the idea of reformatting them. IoT and embedded systems, where we teach not necessarily microprocessor, but how to set up a system. Now we have added IoT because of the importance it has. Our motto is like something IoT in agribusiness. Within the NEON project, we want to work on that. We will create a program of IoT in agribusiness, and also communication systems that will reformulate one new one that may be associated with IoT services, market, business. It's something that has been put aside in a way, but we are interested in reviewing. It is clear that the upcoming of IoT technologies, telecommunication companies, and companies of electronic companies, information technology, well, we're thinking about how to applying that technology, what services are offered, what market we have for IoT businesses, opportunities. So there is a market that demands. This is a hinge moment where there is an opportunity to reach with these technologies, to contribute with the society, to make business. We have a course on wireless communications, a classical course, one on development of products, where we can see how to launch a product into the market. Clearly, we have seen that most projects move into IoT, and one on embedded systems, where attendants develop specific projects working on embedded systems of 90% develop IoT. As part of the NEON program, what we expect to do is to improve more and better laboratories, to make emphasis on hands-on, to give a better profile, specific profile of Internet of Things, and a lot of hands-on laboratory, project-based learning, and closer relationship with the industry, listening what the industry needs and try to get there. An example of what we want to do is this part of these are photographs of a laboratory, assembly of integrated circuits. We opened very short ago. All of these objectives that I stated here are aligned with what the university is doing. It's not new for the university. They're having more hands-on courses, laboratories, and relationship with the industry. There is the printed circuits, robotic in place. It is available for companies and for the students. And this is in the same framework. We want to readjust this laboratory. 2 rooms we have at present. What is the laboratory that requires updating, and the other one that will be linking the both. within the NEON project, this will be our laboratory. We want to set up a laboratory within the NEON project. We expect to improve an aqua laboratory, incorporating them into the courses and make them available to our students and companies alike. We'll work with gateways and LoRa nodes, UHF technology, SDR, kit for NB, IoT, and Android sensors. So we create a working station in a site, setting up sensors so that we can go into the site to set up a sensors network, tailor-made kits, so a large number of laboratories. The idea is to work on Internet of Things. You see, the Internet of Things is a big umbrella that comprises everything. What has changed in the last 2 years to reach this paradigm? It's not that there is a single technology, but there are many technologies that have been creating this notion of Internet of Things that we have to think as a whole. And there are many things involved. Sensors, low consumption, lowering cost, maintenance, going from nodes to the internet. So there is too many things. As I said, we will focus on extending the paradigm of Internet of Things to agribusiness, which is extremely important in Uruguay. So the idea is to extend the paradigm to agribusiness, logistics, distribution of food, and we will focus here, particularly because of the importance for Uruguay of agribusiness. It's a company with 3 million people, 12 million cattle heads, and because of the geography, it's covered by networks. So I could add many other industries that are demanding. There is an opportunity and a need to work with IoT. So the first course, specifically within this field that will be taught in February this year, IoT for agribusiness, where we will see different technologies. Usually in agribusiness, you don't have a connection to electrical grid, so we will focus on low consumption, low power networks, so large distances of communication, low data rate that can be autonomous for many years. This is what is used in agribusiness, geolocation, networks that cover 320 kilometers of extension. So there is a typical example. It's a typical example of LoRa combined with LTE or narrowband. Our objective is to cover some technologies that it is hands-on. We will work with we'll study research with it. We'll review production chains of beef, grains, milk, a visit to rural farms. We'll review the technology of narrowbands and NTV for UHF. That's hands-on. Students will work hands-on because we cannot manage a lot of technology. We will review those modes of communication from Python, from the computer. We are not going to the embedded system, but working from the computer with UHF readers, narrowband, LoRa, and that's all. And we can move on to the questions. Thanks to the NEON project.
Estás muteado, Daniel.
Muchas gracias, Alfredo Arnaud.
Thank you, Alfredo, for your presentation. And now we will move on to Jorge Finocchietto from the National University of Córdoba in Argentina.
Hola, ¿qué tal, Daniel? Hola, buen día a todos.
Hi, Daniel. Screen, the other speaker must stop being a presenter. Thank you.
Bueno, un poco es comentarle, entonces mi nombre es Jorge Finocchietto.
I'm Jorge Finocchietto, and I wanted to share with you our view from the National University of Córdoba, the School of Math, Chemistry and Physics, Natural Sciences, a school that encompasses all specialties in engineering. We try to that we ask ourselves within the framework of the NEON project. Our school encompasses engineering fields. We have 12 engineering specialties, and also we accommodate natural sciences, biology. So we ask ourselves about the scope of IoT when it comes to training professionals. We have 15 degrees, most of them in engineering, and most master's degrees we offer are engineering related. We have over 12,000 students. Ours is one of the biggest schools within the university, and we have a staff of 11,000 professors. So this is our school. To your right, we have a winter garden. Our school has the influence of civil engineering, that is a schoolyard, and at the bottom you see the entrance of our school. So what is the first question we ask ourselves? Do we need to offer a specific degree program for IoT professionals? Do we need a new career, or how to include IoT in existing careers, in existing curricula? So our current strategy is to modify existing curricula. The most closely related careers to IoT are three: computer engineering, electronic engineering, and biomedical engineering. These degrees have between 2,000 and 3,000 students, and NEON is really embedded in our programs. And also there are some degree programs that can benefit from IoT solutions, such as civil engineering, industrial, chemical, electrical, mechanical engineering, and other careers related to natural sciences. We have to give them an IoT view as beneficiaries, so these graduates can understand the value of IoT when solving problems. That is to say, we don't want to limit ourselves to those careers that can offer a technology solutions, but also we aim at those professionals that are going to make decisions concerning technical solutions in many fields. The next question, now focused on specific degrees: are we going to include courses on IoT? Are we going to include IoT in the curriculum, or are we going to review the whole curriculum? Are we going to include a module? Are we going to modify existing modules? So today, we are choosing the second alternative. That is to say, we are working on those topics, subjects, and courses that are closely related to the design of IoT solutions. We are thinking about digital communications, digital electronics. We are working with the curricula of certain courses to include software-defined radio. And also, we are working on more general subjects such as digital signal processing. We see an opportunity here to develop and create new content and to integrate some of the competencies and skills we mentioned before. But we have to take a look at other courses. One course is programming. Programming is mandatory for all engineering students, regardless of their specialty. This is a freshman year course, and we were thinking about including IoT topics in these courses regarding peripherals, sensors, to give future engineers the idea about how IoT can be present in any solution. And we also thought about creating a new course on Internet of Things, a course that is shared by all engineering specialties, not strictly related to developing solutions, but a course aimed at all engineering students, how IoT can help solve any engineering problem. So we conducted some experiences, and this is for people that are not so technically trained. And we see a great value for introducing this topic to all engineering specialties. And the third question, and this question took us the longest to answer: how are we going to create and open these new IoT labs? Do we need new labs, or can we retrofit existing labs? So the IoT group is very much involved in communications, and we don't want to limit ourselves to communications. We want to go beyond that. So we devised this dual scheme. We may expand our existing capabilities, and we are working with software-defined radio and mobile IoT gateways. We are offering a combinations, for instance, with a drone integrated or combined with a gateway in order to collect data in environments which can be hostile, and sometimes you don't have enough infrastructure in order to have a fixed structure. Also, the idea of living lab. The living lab term is something that we adopted in order to depict those labs that can be built within an existing space, such as a university. So, are we going to train professionals in IoT? If we are going to train them, we must show them the value, the use of the things we already have in this context. We cannot show a technology advancement on the blackboard without having actual solutions So we are working in 3 spaces in which we are going to develop IoT solutions that are going to be open to students. The classrooms, we have a project going on, the parking lot, and the garden. We are going to distribute these labs in these 3 areas. So I am going to tell you what I'm talking about. We are working to deploy the labs in the structures we use in order to have an open lab to solve solutions that we actually have in our space. Thank you very much. Thank you, Jorge. Let me tell you once more that all the questions will be answered at the end of the roundtable. So we are going to give the floor to Dr. Juan Cuso from the National University of the South. Juan, are you ready? I'm sorry, my mic was muted, but I'm ready. Many of the ideas we have been already shared with many people that are involved in the project. The activities I am going to describe are related to the overarching goals that I mentioned in my previous talk, and revolve around the landmarks I mentioned before: the updating of the curriculum, the generation of training material, the creation of labs, and the training. Unlike the University of Córdoba, our university doesn't have separate schools. We have departments. Ours is a medium-sized institution, and our department in particular doesn't have the largest number of students, although our history dates way back. But all the activities conducted in the department are conducted with a lab. We have a staff of 150 teachers, all of them researchers working for the CONICET or for other bodies in the province of Buenos Aires. So I&D is really a significant part of our curriculum. So the motivation, the involvement in NEON project goes hand in hand with an institutional project. We have an institute within the electrical engineering department, and the idea of this project and this department is the idea of connecting the academic community with the industry through IoT. So we are developing a number of initiatives in this area. And the NEON activities overlap with the institutional goals that we set up. So I can talk about the updating of our curriculum, and also I can talk about the development of the signal processing lab based on IoT. Actually, we do have an existing lab, and we are going to retrofit it in order to train our staff, our students, with the support of the NEON project. So we are going to have an umbrella lab, so to speak, for all things IoT. As regards the curricula, our department works with electrical and electronic engineers that are involved in all their activities. Nowadays, there's no difference between electronic and electrical engineers, especially from the application standpoint. Electronic engineers are taking courses in IoT. As you can see on the screen, fundamentals of communication systems, telecommunication systems and services, wireless communications and antennae, and special subjects in electronic engineering. These courses can be perfectly adapted to introduce different topics on IoT, and we plan to include them slowly in our curriculum. And we have a specific course, the special subjects in electronic engineering, the content of which can be adapted to a specific topic each year. To cover different topics such as data analytics, network security, applications, and similar topics. At the same time, regardless of the NEON project, in late 2020, the new telco engineering was approved that is going to start formally next year.
There we can see additional courses. Some of the specific courses that are shown here: telecommunication, introduction to digital communication, radio location and radar, or satellite communication, networks, advanced networks, and special topics in telecommunication engineering that will give us the flexibility to introduce specific IoT notions. From the point of view of graduate studies, at present, we have participation in graduate studies in electrical engineering, master and PhD, and at present, we have 2 courses that include IoT content. One of cell IoT technology with very good participation, teaching. It's fundamentally aimed at IoT, narrowband, and another more generic that is intent to provide training on systems, but includes notions on Internet of Things. From the perspective of the laboratory, we have and we are acquiring some equipment, complementary equipment. And in these, particularly with a biased perspective, precisely we expect to complement with other universities, biased in a way because our perspective has to do with training in electronics and communication from IoT. One of those laboratories oriented to self-fed devices, sensors, very low consumption sensors for energy harvesting. Another general laboratory associated to connectivity in IoT, and another laboratory of the design of small dimension antennas. Has to do with the activities described earlier. So I will have no time, but here I had included some details in each one of the laboratories. The idea is to develop the tool in each case and have availability, practical availability to use, to mainstream them in all the courses I mentioned earlier. Thank you for your attention.
Gracias a vos, Juan.
Thank you, Juan. And finally, the fifth speaker of this panel, universities, Leonardo Steinfeld Volpe from the University of República in Uruguay.
¿Estás con nosotros?
Bueno, buen día.
Good morning.
¿Se escucha bien?
Gracias. Gracias por la presentación.
Thank you for the introduction. I will make a presentation of UDELAR in our vision on the teaching and training in Internet of Things. I will start by telling you about our university. It's the oldest university in Uruguay. Has the most students now with a presence in abroad, organized into 5 schools, 15 schools with 150 undergraduate and graduate courses, over many professionals graduated School of Engineering is in Montevideo, founded in 1885, more than 8,000 students, and it's divided into 11 institutes, one of which is the electric engineering, IIE, the one that is a part of the NEON project. Laboratories and offices are here. The Electrical Engineering Institute comprises 150 faculty, 38 have a PhD, 31 have completed a master, and 26 are full-time. The institute is divided into comprises 5 departments. These are the areas: electronics, telecommunication, signal processing, control systems, and power. Participation in NEON through the different departments. The research is divided into groups: analysis, performance, network performance analysis and statistics, wireless systems, multimedia networks, just to mention some research lines, 5G technology, software-defined radio, design, simulation, and manufacture of antennas, and then performance evaluation of different networks, Wi-Fi, electronics department, there is a lot of interaction within each department, even with other institutes in electronics. We have research, applied electronics, microelectronics, and then there is a subgroup that is part of the other group that is focused on embedded network systems. On the research line, within these groups, analog, mixed signals, design of low consumption, low voltage, digital electronics, instrumentation and data acquisition, and finally, embedded systems. The electronic group has a long tradition in what has to do with low consumption, that has relevance for IF. This is just to share some experiences from IoT research and development. Which is representative of what we do. Agrotech, monitoring and control. Side tools, planting, image processing. This to monitor the population pests, traceability of cattle and other biomedical applications, also implantable medical devices and wearable and smart cities, particularly smart lighting. For the different degrees related to IoT, we have two undergraduate degrees, two undergraduate communication systems, and this is a relatively new degree program, and the oldest is electrical engineering that has some profiles related mostly with the 5 departments I mentioned earlier. However, there is a optionality. Each student may define their own profile, and they can each student can make up their own profile and combine electronic with different specialties. So today, the questions that were raised by Jorge from Córdoba, although we do not promote a specific profile in IoT, a student may select the courses that are available, even they are not named IoT, but they clearly are a part of the area of Internet of Things. The programs I mentioned, 450 credits, and take 5 years. And there are other related programs, for example, computer engineering, that in terms of undergraduate studies, and then we have graduate studies, master and a PhD. 5 years between courses and thesis. Both degrees are academic, but we seek in some cases the thesis to be oriented to solving practical problems in the industry, so they are more than welcome. So they are universally accessible. More specifically, training, IoT, these undergraduate and graduate degrees. We offer professional training and more into the proposal of today's talk. There's a motivation in early stages in the program to promote this into students. And what we have been pursuing is active learning. And then we are promoting lab at home courses. And pandemic accelerated this and having remote classes. And the major challenge now is to collect, to make advantage of all the learnings in the last 2 years and apply them to have the best of both worlds. In-person training with the participation, good interaction between faculty and students. And it's something very valuable, but at the same time, adjust to remote learning. These are existing in new courses, although they are not named IoT. IoT is included. And the people that participate in the IoT project. And this is the link. Thank you very much. So that we can communicate regarding the NEON project. Thank you.
Perfecto, Leonardo. Muchas gracias por la presentación. Bueno, ahora...
Thank you, Leonardo, for your presentation. And to wrap up this panel about universities, we are going to answer your questions. Can you hear me? Is that so? Yes. We have a couple of questions in the Q&A box. I don't know, Alejandro, if you can read them. Yes. Perfect. First question by Juan Emilio Busalmen, and it reads, the courses in the National University of Mar del Plata, when are they going to be available? Thank you. Well, on the one hand, our idea is to offer the first course, hands-on IoT. It's going to be developed for next year. And the second part is scheduled for next year, microwave design. That would be a rough estimate, but that is the plan. Some courses are in the making, others are completed, but that is our tentative schedule next year, because we are running out of time in the project. So the second semester, most likely, yes. For Jorge Castiñeira, Benigno Rodriguez Diaz wants to know, do you have the capability of reading MMW signals? Yes. When you talk about microwaves, when you talk about 300 megahertz and above that, millimeter waves. So far we reached 3.5 gigahertz with a spectrum analyzer. And for this, we have requested a subsidy to purchase a spectrum analyzer and a network analyzer up to 8 gigahertz, for instance. So if everything goes well, formally, we will be able to analyze the millimeter wave, but the course contents can be dealt with within the microwave domain. And we need a dedicated software. CT in particular, we are trying to purchase the license with the help of the project. So that would be the idea. In a nutshell would be yes. I don't know if I answered your question. Yes, we think yes, Anders responded. So we don't have any further questions, but I have a comment for Jorge. With our project is going to purchase the CCT. So maybe we can get together and maybe we can purchase this together, and we can ask for a better price. Yes, of course, that would be a great idea, because the retail price is $8,000. And yes, we know that. And in a previous meeting, we got together to make a joint purchase. We talked to Daniel in his capacity as director, and with Fernando. So yes, it would be a great idea.
Tenemos algunas preguntas más, Alejandro.
We have some questions. Nigno, he comments that 8 gigahertz is below the millimeter wave range, and there is a clarification. Juan, would you like to take this question? Or maybe not? Or Casti may go ahead. Yes, it's a terminology question. Maybe there is a debate. Millimeter could be considered above 30, but in practical terms for IoT, the range will go from 4 to 5 or 6 gigahertz, at least at first. So it's enough to deploy this design, working up to that frequency. And that is above of what we can handle today. And this is because of our budget. We didn't go up to 40 gigas because the budget is just not enough. It's out of our hands. Yes, I agree. And from the teaching standpoint, when we organize and deploy the practical work, up to 6 gigas, you have 1 degree of difficulty, and above 6 gigahertz, the difficulty is greater. And the idea is to tell students how to measure. So should I go ahead with the following questions? For Raul Rivera, the hands-on IoT course, when is going to be available? Is it going to be open for students from other universities? Jose Gallardo asks this question. Well, if everything goes well, because we have to build the labs, the idea would be to start interacting in the second meeting, and we want to offer domotic classes and domotic experiences. We want to create a smart city. We want to build it at scale. So the idea is to access remotely to somewhere, to some place. So when everything is ready, and we expect it to be ready on the second half of the year. This is an online course. It's open to everybody. It's very, very highly experimental. We want to do it remotely. We have a virtual course on instrumentation that is underway and it's very successful. So we offer the students, or we suggest the students the use of a very basic software and hardware such as Arduino, things that can be easily found. And the idea for the student to replicate what we show them. We are going to show them how to connect a sensor of an IoT device. That's why we use Arduino. And finally, the gateway, one of the most interesting parts that we want to share with students. So that is the idea, to cover all these topics and to cover them with in practical terms. We are going to show the students online how things are done, because that is the best way of learning, putting up code and checking how it works. As regards Arduino, well, Arduino may seem like a hobby. Arduino has received a great deal of criticism, but it's an Atmel product, and Atmel is in many remote devices that are commercially available. So it's a widely used controller that is very interesting. But in a nutshell, we expect the course to be open in the second part of the year, and it's open to everybody. Leonardo wants to make a comment. Let me tell you something else about the CCT. It's planned for a course in antenna design in order to characterize the antennas that we ourselves design. This is something I wanted to clarify. And this is directly related to the NEON project. And that for the last course, we want to give you an overview of all existing communications technologies to complement this previous course I had mentioned on wireless devices. We use Contiki, as we mentioned before. So, as I told you before, none of these courses is officially a course on IoT, but we are working on it to make them so. Just, I wanted to comment that, and I want to thank NEON for enabling this cooperation among all these universities and among universities and companies. Thank you, Leonardo. Daniel, I have an extra question by Hugo Jorge Mueller. When you mention IoT 4 to 5 gigahertz, what protocols and technologies you are considering? Well, many, for instance, working in 5.8 gigahertz in Wi-Fi, but we are considering other alternatives. Thank you so much for your questions. Thanks to the panelists for their presentations. And this roundtable has been really interesting, and now we are getting ready for the final jewel of this event, a talk by Professor Dimitrios Serpanos. I am going to introduce him in a minute. From the University of... Sorry, Professor Serpanos has got a degree from the Princeton University, researching in IBM in systems architecture for broadband systems since 2000. He is a professor at the University of Patras. He is a chair of the Industrial Systems Institutes, the ISI in Athens. Dimitrios Serpanos is the first Greek awarded with the IBM prize. He's worked in computer architecture, networks, and embedded systems for over 25 years, with an emphasis in the construction and building of real and prototype systems. His main area of research is embedded industrial systems. Recently, he has been a lecturer on smart cities and IoT. He has published over 150 papers in journals, international journals, and in international Congress proceedings. So I want to thank especially Professor Serpanos for his contribution, for his input, and for helping us with his involvement and his participation in this event, for participating and giving us a talk. At the end, he's going to answer all the questions. And we are all ears. You have the floor.
De darnos la charla.
Okay, thank you very much. I hope you can hear me well. Okay, great. Yes. Thank you very much for your invitation. I admit that I was not familiar with your project, the one that is the motivation, as I understand, of today's event, but it is a very timely and interesting project in my view. I was not puzzled, but I had some questions about how to approach this presentation today, considering that it refers to skills and education, and I was not certain if I should put my effort mostly on, course designs and things like that, but I decided to follow a different route. I hope you don't mind, which relates to emphasizing on the problems and the progress of the problems that drive the technologies for cybersecurity, for cyber physical systems and IoT systems, and discuss some technologies that are used now to solve problems for these systems that we had not seen in the past, which indicates that we need new approaches also to our training and skill development for our students. If I can share, okay, let me. So, okay, so I hope you can see my slides.
Yes.
Okay, great. So, As was mentioned earlier, I have been working a lot lately on smart cities, and I think that smart cities constitute one of the major drivers of technologies for cyber-physical systems and Internet of Things systems. I will not argue with the statistics. I'm sure you know several of these things. You know, the population is growing fast. A large portion of the population is aging and needs support. Resources are becoming limited. And on top of this, we have a significant problem that affects everything, which is climate change. This has brought development of large cities to accommodate these populations. From 10 cities in the 90s, we have gone to about 30 cities in the decade of 2010, and we expect very soon, in less than a decade, to grow to more than 40 megacities, as they are called. The important message, because I am sure that you share the need and you understand this need, is that this growth is going to bring a significant growth in technology and in businesses, which is estimated to be already more than 40 trillion invested in urban infrastructure. A lot of it, as I will come to a result into a point, is ICT technologies. So the direction now around the world is to create large, smart and circular cities. Circular from the point of view of economics, because cities offer great opportunities, economic development, access to basic services, and so on. And this is a direction that is estimated to be more than 20 billion at this time. The important thing that relates to the presentation, to the main point of the presentation, is that most of these opportunities and most of this growth is going to come because of the pervasiveness of digital technologies and the development of new digital platforms that actually interconnect Internet of Things systems and cyber-physical systems mostly. The expectation is for these technologies to bring us to a point where we have smart and so-called environmentally neutral cities in the near future. You know, just as a couple of examples to indicate the application domains where our technologies apply these days are Barcelona, for example, which has a highly integrated approach exploiting, of course, ICT and cyber-physical systems that combine combine street lighting, waste disposal and waste disposal management, transportation by managing the public bus system, irrigation of squares, super blocks, building blocks for small neighborhoods, as well as infrastructure for the subways. And this is only a step towards a goal that is probably led by Singapore, who is the city that you may know is usually getting awarded for its initiatives and its leadership in this direction, which has 5 basically key national strategic projects. And all of them relate to digital transformation and cyber-physical systems. The first one is the National Digital Identity Framework, which means that the government is making an effort and establishing the infrastructure to establish digital transactions everywhere in a convenient and secure fashion, and especially for e-payments, a specific strategic project that leads to simple, fast, and safe payments. The country, the city or country of Singapore is actually building a smart sensor platform from border to border, with accelerated deployment of sensors that are going to be available everywhere and measuring different parameters ranging from climate to security, I mean physical security, and include lots of IoT devices as well in their platform in addition to the sensors. Considering the size, for those of you who have been to Singapore, smart mobility is another initiative that is very important, focusing on public transportation systems based, of course, on ICT technology. And all of these platforms and initiatives are going to be integrated in a large effort that they call Moments of Life, which relates to services provided to citizens, digital services that are provided to citizens with a one-stop shop. For this type of development, one needs to have a holistic approach. And this is something that we should keep an eye on in the future. In order to establish smart environments like the smart cities, we do not only need the infrastructure, which already poses to us several problems, but requires also coupling of this infrastructure with appropriate management. Management has to be also efficient and effective, and of course relates to governance and policy. And although policy is probably out of the scope of what we are discussing today, we should remember that governance actually is the activity that actually places the requirements on the infrastructure that is being used, especially at the national levels. And the infrastructure needs to be able to accommodate all the services and initiatives that governments require. So we have a multi-factor integration need in order to have a successful business plan. And these days, it is my feeling at least that infrastructure cannot be developed, especially deployed at the level of IoT and cyber-physical systems without having governance and policy issues in mind. Because just to make a relation to what I'm going to say later, because these technologies, for example, relate a lot to safety of citizens, public safety, and so on. So they need to be coordinating with governance and policy. So what are the challenges that smart cities, for example, as one big application domain brings to us, for the IoT and cyber-physical systems? Basically, as I'm sure you already know, we need systems to be smart everywhere, from energy to communication, to water management, to transportation, street light management, parkings, health systems, of course, which are very important, as well as education itself. Digitization of education, at least in Europe, is one of the major priorities for the next decade, especially considering the adoption of the technology and the growth of the educational digital services that came in the last 2 years during the pandemic, when schools were closed and students had to be remotely connected. So what are the ICT challenges? I assume that most, if not all, of the attendants here are ICT people, so probably this is the more interesting part after the requirements. The ICT challenges that are coming to us from all these domains have to do with several disciplines or subdomains, if you will, of engineering that we typically consider up to now as separate domains or separate fields, like embedded and cyber-physical computing, the development of systems, development of communications and communication systems, social computing, cybersecurity, especially with a focus on privacy, but also related to safety, as I will discuss a little bit later, artificial intelligence, and so on and so forth. And these challenges, of course, they include several more detailed challenges for those that I'm sure many of you already know since you are active in these areas. In cyber-physical computing, the development of new embedded architectures is a challenge, especially in the domain of low-power electronics, considering the devices that are being deployed autonomously in the field. The design of systems, interoperability problems, for example, the high requirements, strong requirements for dependability on several of these systems. For example, consider vehicles, industrial systems, building management systems, and so on and so forth. And of course, the detailed Internet of Things and industrial Internet of Things, especially edge computing and the accommodation of artificial intelligence, especially the last few years, considering the developments of AI and machine learning in all directions. Communications are another significant challenge. As you know, cellular network infrastructure is getting saturated little by little. There are more requirements coming from new networks and new communication demands from, for example, machine-to-machine communications, the development of 5G. IoT deployment also leads to the deployment of IoT dedicated infrastructures. And this creates significant problems in the urban environment where wireless technology is being used widely for several reasons, because energetic autonomy is a requirement. New IoT operators, especially at the urban level, are being developed, and existing infrastructure needs to be exploited. Social computing is another significant challenge in this domain. Most of these applications, especially from the government's point of view, are directed to citizens. Of course, the same holds also for businesses who are developing the e-trading infrastructures and electronic commerce infrastructures. So they need to get to people very fast and easily. And in order for social computing to be effective, what is to develop application technologies like data mining and sentiment analysis in order to focus on aspects that are of importance at times, based on area, time, and so on. Cybersecurity is, of course, another significant challenge. As many of you have experienced, I'm sure, at several times, like everybody, we need for cybersecurity solutions to come and provide service availability and security for these services, for processes, for the data that we are using, considering the development and the dependence of many services on cloud. Cloud security is a significant challenge also in this domain, in the IoT domain, because the way IoT, for example, systems are used, cloud is a necessary coupler to IoT systems. And of course, there are issues of and public safety, including surveillance systems, and many more challenges, as I'm sure many of you have experienced, that have to do with system interoperability, application interoperability. Open data are becoming an initiative for many states and governments, also for market development, the ability to establish end-to-end trust, to use AI everywhere, and so on and so forth. Last but not least, a question about standards that although we are already experiencing a significant geometric growth to IoT systems and services and cyber-physical systems and services, standards are still in lack. So we need to put a lot of work on standards. So what does this mean for us from the technology point of view? These are challenges that basically cover all the areas that one would categorize under probably electrical and computing engineering. So how do we approach the development of these systems? And here, I'm going to give you more of my own approach, I mean, my team's approach to cyber-physical system development, and especially to the development of robust cyber-physical systems and IoT systems by looking at some of the problems, the new problems that have come up with the development of these systems and their use. So what is, there is, by the way, some lack of, let's say, accepted terminology in the area of Internet of Things and cyber-physical systems, because people are using these terms interchangeably or sometimes a little bit differently. I'm going to use them interchangeably, but I will try to give at least my approach to the Internet of Things, which basically I consider it as an Internet of cyber-physical systems. So what is the Internet of Things in many ways in the mind of many people? It's an information network of physical objects that connects, for example, sensors or machines or cars, buildings, and so on. And these objects interact with each other and cooperate to achieve some goal. So smart and CPS, cyber-physical systems, is because it's basically a large connection. A smart city is a large connection of these smaller internets. The systems that are connected on the Internet of Things are typically designed for one or a small set of applications. They do not constitute exactly a collection of Internet-enabled devices with the concept that we used to have, for the Internet and the systems that are connected to the Internet. Since these systems are cyber-physical in nature, I mean, they include a physical component in the system itself, one needs to take into account the dynamics of these physical systems. And this indicates that we need to address and understand the processing of the signals in these systems. The spread of MEMS, by the way, is actually making the problem more acute, or the challenge, if you will, not a problem necessarily, a challenge more acute, because MEMS are actually spreading everywhere, and because they have low cost, they have low power requirements, they enable a large number of applications, but at the same time, from the engineering point of view, they push these systems more towards signal processing methodologies. A significant part of the Internet of Things, which I consider typically also because of my personal research interests as a different, a separate part of the IoT, is the industrial IoT, which is basically the use of IoT technologies in manufacturing. It has many common aspects and issues as the average IoT, but this one focuses more on machines, machine-to-machine communication, and automation technology plays a stronger role in this direction. Smart machines are actually being developed and adopted in many domains of industrial development. And as we all know, the technologies of big data and data analytics, as well as machine learning and artificial intelligence, are increasingly adopted in this direction. The importance of the Internet of Things, the industrial Internet of Things, in my view, comes from the fact that it is stricter. It requires resolutions of inefficiencies and problems faster. It enables also the resolution of problems faster, and it enables us to achieve quality control, sustainable green practices, and so on. And this is the reason why in several parts of the world, there are specific efforts that are trying to cover the missing part we mentioned earlier, like standards and common practices, best common practices, and so on, which are, I assume that you have heard many of these efforts, like Industry 4, which has been adopted by Europe. It started in Germany, the Industrial Internet Consortium in the US, Society 5 in Japan, and Made in China 2025 in China. These are efforts that actually relate strongly to the development of technologies, the establishment of standards, as well as for education in Internet of Things technologies. So what are these technologies that pose a challenge to us? At least a challenge to the older ones, I would say, of us, who have been trained as engineers. So cyber-physical systems and Internet of Things technologies are actually an interdisciplinary area that is emerging. I will focus on the term cyber-physical systems because it indicates the inclusion of cyber part and the physical part of these systems, which in many application domains have to be addressed uniformly as one system. It's a system that incorporates, integrates, if you will, computation with physics typically. And in order to analyze these systems and to be able to build them, we need to be efficient and fluent with several aspects of engineering and mathematics, like algorithms, logic, control engineering, and so on. And let me indicate this with an example that is of strong interest to me. It constitutes a focus area for me. And this is the area of safety and cybersecurity. For example, consider a car, which is a complex cyber-physical system that includes small, let's say it's an Internet of Things system also, in the sense that it interconnects several smaller cyber-physical systems. So from the point of view of security, cybersecurity, I mean, one is interested in establishing the integrity and confidentiality of the information that is being transmitted and processed and stored in a vehicle. On the other hand, safety is a property that needs to characterize this system, and as we all know, it relates to the avoidance of physical damage and harm of the human being, human beings that are in the car. Safety and security are actually two characteristics that are heavily interdependent in the case of a cyber-physical system like a car. However, traditionally, from the educational point of view, as well as the market point of view, safety and security are traditionally handled by two different groups of people, two different groups of engineers. And here we are not talking about simple systems that one can easily manage, but we are talking about highly complex systems. You can see some of the statistics, for example, of two cars that are mentioned on the slide. The Ford car has more than 150 million lines of code, and an airplane, a Boeing 787, has more than 7 million lines of code. So one can imagine what may happen if some property of security or safety is being violated on these systems. And apparently the management and the development of this large software system is not something that can be trivially analyzed or examined. And this difficulty, in my view, comes from the difference of, or the shifting, if you will, of the traditional IT technology to operational technology, as many people call it, the computational technology in the field for cyber-physical systems. Most of our training, actually, up to now, and education has been focused more on IT technologies rather than OT technologies. And this becomes clear if somebody looks at the differences between IT and OT through different parameters. For example, in information technology and the focus of many engineers, the goal is to process transactions, I mean, for many applications. Of course, this is not an exhaustive list here, it's just indicative about that, you know, most of the IT systems are actually executing transactions and provide information. They serve information to users and to organizations and so on. On the other hand, in operational technology, systems are actually controlling physical processes. And the difference here is very, very significant because it influences, first of all, the characteristics of the input to these systems, as we will see in a little while. Architectures up to now for IT systems have been based on common infrastructure that is enterprise-wide, while in the field, in operational technologies, in systems like the ones we are focusing on, IoT and CPS, systems are event-driven. They have real-time requirements. They have a lot of embedded hardware and a lot of custom embedded software. Interfaces are very different. In IT, we have GUIs, browsers, terminals, and so on. In operational technology, in cyber-physical systems, we have sensors, actuators, handheld devices, and so on and so forth. The importance of IT up to now is also indicated by the ownership. As we know, in many organizations, there exist roles like CIO and IT vice president, while in operational technologies, where the developers and the owners of the systems are usually lower level in the ranks, engineers, technicians, operators, and so on and so forth. And these differences indicate the way actually that the focus of technology development has also come to fruition up to now. IT is definitely, and IT characteristics are the ones that have been drawing most of the attention up to now, which needs to shift to the characteristics of the right column, as you see on this table, for operational technology, because these are the characteristics for most IoT and cyber-physical systems. And personally, the way that I look at these things, I mean, the cyber-physical systems and IoT systems is by looking at them from different angles and from different points of view. So considering, for example, a typical cyber-physical system, which means, focuses on some kind of machine or device that you can see in the lower part of this figure, actually, most of these cyber-physical systems, from the control engineer's point of view, are actually a closed control loop. Usually there is a process, as we have the machine here at the bottom part, we may have a physical process that is being monitored through sensors. So the sensors take measurements. The measurements are transmitted to some kind of a control center, and the control center decides if and what needs to be done and delivers, the decisions for actions through actuators. This is the typical view of the control engineer of a system. But in reality, this control loop that is implemented as an application usually is implemented on an infrastructure that's a computing infrastructure and which is structured in a different way. Before getting into this discussion, I want to emphasize that I'm going to talk a little bit more focused on cybersecurity and safety as an example of a requirement, a set of requirements, two requirements, the safety and security are different, that are coming from the cyber-physical domain, because safety is a characteristic of the cyber-physical domain. And I'm going to focus on that and demonstrate, to show you how I understand at least some of the problems and how some technologies can be combined in a new way to solve this challenge. So thinking about security or safety attacks, risks, if you will, in this control loop, if you ask the control engineer what may go wrong in this picture, actually, they will tell you that, every single point of this loop is a point of failure. Sensors can go bad, communication can center, which is a computer, may be attacked. The same goes for actuators. Even the process itself may be messed with. So how do you approach this problem when you know that this is, for example, you have security technologies that can help in this direction, but at the control engineer's point of view, this is not a typical approach. So if you look at the same system that we saw before, the control loop, actually in most cases, in many systems, especially in industrial environments, this control loop is implemented through a different structure, a different computing structure. Actually, the computing structure which implements typical control loops, this is for the industrial environment as an example, but it's not the only one. You can see analogy in most cyber-physical systems. You have different levels of computing systems of different strengths that are being interconnected. So in this hierarchy, for example, at the bottom layer, you can see the systems, the physical systems, and the related sensors are indicated here that are connected through some kind of sensor network. They give their data to some simple devices, field devices, like PLCs in most industrial environments, which are then interconnected, and they are controlled by a larger system. In industrial systems, it's called the SCADA system. It's a supervisory system that actually runs the whole process. So you can imagine, for example, that you may have here a small plant that is being, that's actually the term that control engineers use. You have a plant, and this plant is actually measured by sensors. The PLCs are doing local calculations, and then there is a large system that actually does the overall calculation, manages the whole system. The important thing you can imagine, for example, in an analogy, that instead of having these systems, valves or pumps, you could have different types of sensors in a system that is monitoring patients. You could have different sensors that are being accumulated in some intermediate system that makes decisions on a specific on a specific parameter, for example, temperature, pressure, or whatever. And then all of these different systems are being coordinated by a larger system for a patient or a set of patients. So in this is the typical way that things are being implemented. And this is, let's say, the computer engineer's point of view of the cyber physical system, while the closed loop is the view of the control engineer for the whole system. So in this system, from the computer engineer's point of view, you know, so you see some characteristics that actually influence technologies, decisions, and the way the system is developed. For example, the hierarchical structure is an important constraint. The requirement for heterogeneous technologies to be included in the complete system places challenges on the system. You have autonomy requirements because these systems need to operate in the field under, in many cases, under uncontrolled conditions. And in many environments, you actually have requirements for continuous operation and fail-safe operation. If something goes wrong, the system has to fail in a very specific and controlled way. You have high dependability requirements, and actually the system indicates that there is dependence on large numbers of inputs devices. You have to manage lots of sensors and potentially actuators. In some environments, you also have to take care of some other aspects like legacy systems that you have to include and incorporate in your larger system, and increasing connectivity. If you look from the computer engineer's point of view, as I mentioned before, actually the attacks become a little bit different from the ones that the control engineer sees, in the sense that you can see computational attacks on the computing systems. You can see transmission attacks, communication attacks on the networks themselves. But here, if you look carefully, there is also another attack that I will spend a few minutes discussing later that relates specifically to IoT and cyber physical systems, and is the class of false data injection attacks that are actually attacking the interface between the physical part and the cyber part of a cyber physical system. And for these environments where safety is an important parameter, an important constraint, because many of these systems relate to humans, you have to provide very strong requirements of resilience, continuous operation. Many of these systems need to continue operating even when the systems are under attack. And here I will augment the term of attack and say also accidents also, that the system should be continuously operating even under accident conditions. And of course, systems need to mitigate attacks and recover. So how do we do that? I'm not going to tire you with details, with many details, but I want to discuss a little bit the technologies of how, for example, we can build safe and secure cyber physical systems, combining technologies that in the past were considered as separate and were being addressed by different types of engineers. So in order to build, to have a safe and secure cyber physical or IoT system, we have to consider two things. The first thing is, in their lifetime, in the lifetime of a cyber physical system or an IoT system, actually we have two very different phases. The first phase is the building phase, when we design and we build our system. And the second phase is the life of the system in the field. And these two phases are very, very different because of the conditions under which they operate. Of course, when you build a system in a controlled environment. and you can build it with the requirements and specifications which you have received or you have set. But when the system works in the field, especially an IoT or CPS system, which works in sometimes hostile environments or unpredictable environments, there are conditions or assumptions that you have made that may be violated, or maybe the assumptions do not hold. So how do you do these things? You have to take care of, with different technologies actually, the two different parts, the building part and the operational part. Because when you build the system, actually you need now more than ever to be able to prove properties of the system you are building at the hardware and at the software level. When you deliver, for example, an injection, a pump for insulin, you have to provide specific safety properties. And really, if you really think about it, you have to be able to prove properties about your system, the one that you are deploying. So how do you do that? We know that you can do this thing by developing your system, hardware or software, and either verifying your system or testing your system. Testing is an interesting approach that works in many environments, but in my view, at least, is not fully capable to manage this problem, at least for cyber-physical systems which have strong safety requirements. So actually, if we want to develop systems, and that's what I believe, we need to prove properties for them. Then we need to follow approaches that enable verification of our systems, formal verification of our systems, in order to ensure that we have the properties that we ask for, we specify for our system. So in order to develop our system, for example, I'm discussing some parts of some work that we have done for developing a monitor and an industrial system that is actually satisfying specific security and safety requirements in the field. So how do we develop this system? We have an environment where we are actually describing the specifications and the constraints, the properties that we want our system to have formally in a verification tool. Specifically, we use the system COQ, if you know it, which is developed by INRIA in France. And we are describing our system in an executable specification, as well as the constraints that this system needs to satisfy. Then we develop a monitor. We develop a monitor which we deploy so that the system can be monitored when it is in the field. Building monitors is a skill, let's say, something, some technology that is actually very different from the development technology that I mentioned before for verification. Actually, it is related to verification because it is runtime verification. Actually, some of your partner universities in Europe are very strong and very experienced with these technologies. But the important thing is that when a cyber-physical system works in the field, you are required somehow to monitor and ensure that the system is operating as it is supposed to operate. It is supposed to operate within specifications. So we have developed methodologies, and I think that this is an important aspect of training and education these days, that for developing monitors, runtime monitors that are doing verification of properties for the systems that we are developing. And another aspect that I consider very important is to develop methodologies, to have methodologies that enable the analysis of our systems for vulnerabilities, where vulnerabilities are not necessarily vulnerabilities for cyber attacks. They may be vulnerabilities also for accidents. And these type of vulnerabilities need to be addressed for our systems at the architectural level. So we need basically risk analysis and risk management methodologies for our systems. And I will describe to you briefly in a few minutes one such methodology. Of course, it's not the only one, but it's indicative. So I will go through these slides a little bit faster because I don't want to tire you with technological details, but I will be happy to answer questions for you if you have any after the presentation. So the methodology that we are using, and I think that I believe that actually it's the methodology, it is a methodology that is being adopted by many people independently and with different tools, is to spend significant effort and develop new technological tools for building our systems with provable properties. Cyber-physical systems, I mean, and Internet of Things systems. Then we need methodologies to develop appropriate monitors for the specific processes and applications where our systems are being used. And these are heavily application dependent. I mean, you build these systems, for example, if you build a system that is monitoring, for example, an electrical grid, it's a very different requirement than building a monitor that is monitoring a car. Although the basic principles may be the same. The reason is that the use, the process, the application of these systems is very different. And many of these properties that when we are talking especially about safety have to do with the process itself. So as I mentioned, we have developed, I mean, actually the COC itself is doing, it has been built in some way to do this. We start from a high-level specification, and by stepwise refinements, we develop our application code. And then I see that I have spent more time than I expected, so I will spare you the example. But if you have a question, of course, I will be happy to come back. And then we have a methodology to build a monitor, which is the box in the middle here. It's part of a larger architecture that I will explain in a minute, which does the following. First of all, starting from the bottom, what we have to the left, the application specification is basically a program, executable specification. And on the right side, we have the code executed on a cyber physical system itself, the specification and the implementation. And actually, we are executing them in parallel. And we are comparing the specific parameters that we choose for the specific application domain. When we see differences through this behavioral differencer, then we raise a flag, which means that there is a problem. Just to give you an idea, in case I have confused you, let's consider as an example that you have, for example, a water tank. And your water tank contains water, and you want to avoid some overflow condition and some underflow condition. Then your application specification basically includes the description of the controller of the water tank, plus the constraints that, the height of the water should not go, beyond a specific number, or underflow condition under a specific number. And you feed these things to this tool that we have, and you get some code. The code is the one that is in the right box, application implementation. And these two pieces of code are being executed in parallel. So the specification is going to calculate what the water level should be after a specific set of instructions by the user. The application implementation will measure it. If you find a difference between the measurement and the prediction, then you know that you have a problem. Then in order to find out what the problem is, then you have to go through diagnosis, identify the problem, and then go through a phase of recovery and regeneration in the direction that I mentioned before. So this way, actually, we are building smart systems that are self-aware, that are allowed or enforced, if you want, to behave legally. Legally means, according to specification, and we can detect all different types of failures or accidents. It doesn't matter if it's an attack or an accident that causes a problem. We always detect it. So let me spend the last few minutes, because I think that I am close to my time, the last few minutes to discuss one specific characteristic of cybersecurity and the safety risk that exists only in cyber physical systems and the Internet of Things systems. So this is, traditional computer and network security. We always considered problems, with the storage, processing, or transmission of data, but we never examined, for example, the legality of the input data that is inserted to the protocols. Cryptographic algorithms, for example, have been developed considering that the input may be completely random. In cyber physical systems, where you are monitoring physical processes, things are not exactly characterized like that. And actually, there is also a risk that has never been considered, in the traditional IT environment. And this risk is the risk of somebody attacking the interface between the physical part of the system and the cyber system and injecting false data. Just to give you an idea of where I'm driving it to is, everybody knows the example that if you have in your in a room, if you have a temperature sensor that is connected to a fire alarm, if you go and you light a lighter next to the sensor, the fire alarm will go off. And this means that the fire alarm will signal that there is a problem, there is a fire, although in reality there is no fire. So what has happened here? What has happened actually is that somebody injected to the system false data, and the attacker actually attacked the system by leading it to an inappropriate decision, by misleading it through the data that it sent to the system. So somebody in this example does not really need to attack the alarm system itself. It does not need to send a virus to change, for example, the program that it's running. The only thing one needs to do is just to light a lighter next to the sensor. This, if you think about, this problem exists in all systems that that are attached to sensors, where sensors are measuring data. If somebody injects inappropriate measurements to the system, that can lead the system to the wrong decision. And actually, this may lead the system to distraction. One of the concerns when these type of attacks were first considered, one of the major concerns was what happens, for example, in the electrical grid, in the grid of a city, if somebody does an attack like that. If somebody goes to the transformers, for example, and changes some of the measurements, as you know, the state of the grid is used, for example, to identify the future demand of energy for the city. So somebody may go to, especially in free markets, somebody may go and order extra energy, for example, where energy is not necessary. Or if, the other way, if somebody makes an attack, they may lead to somebody, not ordering the appropriate amounts of energy for a specific city. the system may be completely misled. This is an attack that actually can be, has been experienced, and it can be experienced in several directions. Up to now, luckily, most of the places where such attacks have been identified have to do with irrigation, water irrigation systems, because people wanted to steal actually water and send it to their fields without, the water company understanding what is going on. So they were going and messing with the sensors, although the system was operating in a completely different way. The water was going in different places. But this type of attack has potentially lethal, can have potentially lethal consequences in several environments, for example, cars. So one of the problems that we addressed and we wanted to understand is how can we design systems that are not vulnerable to this type of attacks, to this type of risks and interference. And this is not actually an easy problem. Actually, it's a very difficult problem. I will not get into many details. The reality is that you cannot avoid all different types of attacks in a system, ever. There is a proof for this. But the point and the important thing is you can limit them to such level that are not actually creating problems, that if you can restrict them to the level of noise. And, systems are built to manage noise. So if you can restrict the systems to be analogous to noise, these interference to be analogous to noise, then you can build a robust system. So how can you identify details? But I can tell you that a surprising solution to this problem comes from a different domain, and this is the satisfiability domain. I'm sure you are all familiar with satisfiability problems and how they are being used for verification in several environments. Here we do the following. We have an expression for the satisfiability problem, which actually is not with a binary function, but it's with a real function, a function over real numbers. So what we do is that we model the process that we are studying, for example, the calculation of the state of the electrical grid that I mentioned before, with a set of equations, the power equations in this case. These are real functions over real numbers. And then we consider that we have a monitor. This is the monitor that's shown in the slide here as monitor x, z, where x are the process variables and z are the measurements. And we express a question, a satisfiability type of question, which is stated here as FDI of z, which says, does there exist a measurement that is not correct, but it passes through the monitor, which means that somebody is inserting bad data, incorrect data, but the monitor cannot catch it. Actually, it's surprising, but if you go through the details, you can actually express this type of question with real equations and constraints over real numbers. And we use a tool. I don't know if you are familiar with this tool because this is relatively new. It's called DReal, but it solves satisfiability questions for real functions over real numbers. I'm sure you all know Ed Clark. I mean, he's a Turing Award winner. He has been working on circuit verification for a very long time. He had been solving the satisfiability binary problem in many different ways. He is actually one of the co-authors of DReal, and he has developed this tool with a student of his that I had the pleasure of working with, and this tool enables us to identify attacks on cyber-physical systems, false data injection attacks, and risks like this on cyber-physical systems by solving satisfiability problems. So there is a transformation, let's say, of the risk problem to a satisfiability problem. We have done this for the power grid. We have actually done it with benchmarks that are universally accepted, and have gotten very good results. We have demonstrated the feasibility of the solution. So as I think I have overrun my time, I apologize for this. I would like to conclude saying that basically, I hope that I have convinced you, although based on the previous discussion, I don't think you need much convincing that, Internet of Things systems, the development and engineering of Internet of Things systems and cyber-physical systems, as well as their applications, and is an interdisciplinary emerging area. It requires skills from different domains. One needs to understand computation very well, but one also needs to understand the physics of the processes that are being controlled by these systems. One needs to be very fluent with algorithms and mathematical logic. For example, if we are talking about software verification, as I mentioned before with the COC tool, but one also needs to understand control and have a control engineering approach to these systems, because they are actually implementing or influencing, addressing control problems. So actually, we need to develop new skills. We need to integrate these skills to people, to students, and we need to address things that relate, start from internet computing and relate to software engineering, because even the web applications that we are using and we are loading on the IoT and cyber-physical systems actually influence a lot of their operation. They influence their specification in the sense that I mentioned before. Robust architectures are very difficult to develop, and they need to be addressed at all levels, from components and electronics to the system level to the application level. Formal methods, an aspect, a discipline, if you will, that was traditionally considered as part of theoretical computer science, actually has become practical and needs to become part of our curricula. And our students, the new generation of engineers, need to be fluent with formal methods, because most of the tools that are coming out now are actually based on this. And they have to understand the difference and the mathematical properties and the meta-mathematical properties, if you will, of verification and testing. And all this, of course, relate and are very closing. Let me say that, let me close with a philosophical type of note that, in my view, this, the journey through all these technologies and skills, to me, indicates that actually, instead of building our curricula, engineering curricula as well, as disciplined as we have up to now, I think that we have to go a little bit in a different direction. I think that our programs, especially including the engineering programs, have to become more liberal. And actually, this is indicated by the interdisciplinarity of the engineering that is required for IoT at CPS. But in addition to the engineering interdisciplinarity, the application effect of all these systems requires some of the new engineers to be also knowledgeable of other aspects like sociology, like medicine, health. And in this direction, I believe that university programs need to be a little bit more liberal than they are today, at least in most of the countries that I know of. So I hope that I addressed the issues you expected. And thank you very much for listening to me.
Muchas gracias, profesor.
Thank you very much, Professor Dimitros.
Thank you.
Thank you for your presentation. Now we are going to proceed to some questions. I understand there are some questions that perhaps have not been sent in writing. They can be done orally if you like. I can start.
Sure.
And thank you for the presentation. It's been very clear, very interesting. In the framework of this talk, we discussed the security systems failures and particularly the sensors of the number of lines of code lines. And in this field, I understand vulnerabilities identified when it's there. In industries like aviation, are there techniques to predict a safety vulnerability before it happens?
You mean to identify early something that is happening in the field, or be prepared for a specific vulnerability?
Both.
Both.
Okay. For the depending, of course, on the system, but the presentation that I did for the methodology for the industrial system actually could be also for an aviation system. So to address the aspect from the two phases that I mentioned before, the design phase and the operational phase. So if one of the requirements that is set for the system and the corresponding specification that a specific condition should be detected early enough, then it will be built in the system so that the detection of the risky conditions, let's say when they accumulate, it will raise an alarm early enough. This is an application requirement that can be easily integrated as long as it's explicitly expressed from the beginning. Based on the assumption that the system is built with a monitor, monitoring its correct operation, I mean, and that we can be fairly reasonably certain about its operation, then it will certainly make a detection if it's built appropriately. To be more precise, for the methodology that I presented to you for the monitor, actually with the specific approach, we have a proof that any kind of computational attack on the system or accident that is equivalent to a computational attack will be detected. And I actually have a proof that the system that will not have either false positives or false negatives for the specific class of attacks. This does not include the false data injection attacks, for example, but it includes a large part of the attacks.
Thanks. Thank you very much.
You are welcome.
¿Alguna otra pregunta?
Do we have any other questions? Well, I have a question that has to do with educational aspects. Specifically, I'm thinking about the philosophical statement about the curricula, particularly we in Mar del Plata University, we are right now in a significant process of changing curricula, reforming curricula. The NEON project specifically promotes the incorporation of the topic of IoT in curricula. And also, precisely in this meeting, that we have had businessmen, entrepreneurs have claimed that the curricula should incorporate a lot more content related to entrepreneurship, project management, financial management. That is, that we encounter the curricula need to include multiple aspects and almost tend to become encyclopedic in a way. I would like to ask you what you think about that, because that ultimately, which on the one hand, society is demanding the incorporation of so many content from different fields, does not work against the quality of the education of the engineer?
This is a very interesting question. I think this is a question that's actually troubling many people around the world. But I don't know. I will give you my personal approach. It's not the approach of my university, but I can tell you my feeling. As you noticed, my talk started with smart cities. The reason that I started with smart cities is because in my mind, I start from an application domain to collect requirements. And from the requirements, I get to specifications. And from specification, I define specific problems for me to solve, and do the research that I want to do. Whether we like it or not, many parts of society work this way. So in businesses, actually, we have noticed the following. First of all, I don't know if you're familiar with the geography of Greece. I live in the western part of Greece. The university is the third largest university, and actually it's the most connected outside Greece with the average student, in the average degree, let's say, from all other universities in Greece. And it has a very innovative engineering school. It's the first school in Greece that established an electrical engineering department back in the 60s when, most universities had electrical and mechanical engineering at the same time. And in the 80s, it started computer engineering separately and so on and so forth. And it was very relevant to the market. Now, though, although in Greece, the university was very strong, for some time we had businesses around us, engineering businesses, but at some point they left. And now they are coming back. And when they come back, you know what they say? They say, okay, we are very happy that you are giving your students such a formal education, but, we don't care for what you really teach them, because we are going to train them ourselves for the consulting business that we are doing, for the systems that we will be building, and so on and so forth. That, to me, is an alarm. And it's not happening only in Greece. I know that it's happening all around the world. The businessmen and the business initiators, they train their own employees the way they want, because they want them to be within the spirit of the business model that they are developing. And this model actually has been proven very successful in the US, as you know, and then the Western world, wherever it has been established. What I'm trying to say with all this mumbling, I hope I'm not tiring you, is that actually I think that the market all over the world is disconnected from the university, does not like very deep and very specialized knowledge for the undergraduate students. It wants graduates who understand applications, requirements, domains, and they know how to run projects and get things done from A to Z. And that requires skills to plan financially, skills to plan your project, accumulate the resources that you need, and deliver a result. And if you are able to start from a real need in the market, then you are an entrepreneur. And that's the model that most people see it working. So I think that although we do not like as faculty the idea that we will not teach our students deep thinking, I think that the society itself, at least at this point, needs a little bit more a wider spectrum. And that's why I believe that also we should be a little bit more liberal with our problems and with our curricula, because that's the way that we bring interdisciplinarity to our curricula. Otherwise, it's just the curricula that we have grown up with. So I think that we need to listen more to the societal and business needs and let our students a little bit freer.
Muchas gracias.
Actually, this is one of the questions that
Thank you.
I was seeing in the chat. Please use the Q&A panel instead if you want to ask anything.
Hay una pregunta en el chat.
There is a question in the chat box.
It was exactly that.
When I say more liberal, okay. Most of the engineering curricula that I know of, actually students are required to take strict programs of courses, and they do not have many electives from other engineering disciplines or from disciplines that are outside engineering schools. So, for example, when I was a student, I was allowed in my first year to take a class on economics or management. But after my third year, basically, I had only electives from engineering. What I believe is that actually the number of elective courses should be increased, and actually engineering students should be required to take more courses from outside engineering. I mean, it's very good to be good at math, to know all the methodologies, to do signal processing, 100 different ways to write applications and so on. But at some point, you need to understand a little bit more about how to use, the discipline of signal processing per se, to do a sociological sentiment analysis. If you do not know what sentiment analysis is, it will never cross your mind. You need to know. So how will you know if you are not educated with this? So I think that, of course, there are many issues that relate to the tastes of students and so on. I'm not saying that all students should take sociology per se, or that they should take medicine. But there are students, undergraduate students, who have very, very concrete ideas. Actually, if you have noticed, in many parts of the world, many of the undergraduate students are the ones who are coming with great ideas, and most of them are not the first day students. They are the students who are actually passing through their courses, but they are interested in other things. I mean, think, for example, the agricultural domain. I had two students coming to me from a different department. I'm in electrical and computer engineering. There were two students who came to me from computer engineering, and what they told me actually is they asked me to do their undergraduate thesis using blockchain to do agricultural applications. And when I asked them how they came up with this idea, they told me that their parents are agriculturists. They want to do something that relates to what their parents do. I mean, these guys could be very good at health if they could take some health courses, but with our curricula, they will never get a health-related or medicine-related course. We have now we have a graduate program, master's program, that combines computation and medicine, but it's only at the graduate level, and it's only for, let's say, 20 people a year. People cannot, undergraduates cannot elect any courses from there. I use the example of my university, knowing that many universities, I mean, I don't know the specifics of universities in Argentina, I confess. So if I am out of scope, please let me know. But I know that in most European universities, for example, the situation is like the situation in Greece.
If I can comment about that, I agree that in Argentina, at least, is very similar to Greece in that aspect. But one question, because related to your experience, you talk about liberal study programs. That means to offer more opportunities for students. But in the European system, there are competencies that must be defined. So how to work in that trade-off between open curricula and competencies?
Well, I mean, when I said more liberal, I really meant more liberal. I didn't mean liberal, you know, across the board.
Yeah.
I mean, in the sense that I know, for example, in the US, some universities have very relaxed requirements. I mean, you can become an electrical engineer with 5 courses in electrical engineering and all the rest, you know, being different. I'm not talking about that either. So you have to follow, in my view, a balance. But I think that right now, the rigidity of the European engineering programs is very, very high and needs to be relaxed. Because I think that the skills and the competencies that you refer to can be developed easily with the programs we have. I mean, I don't know for Argentina, so I'm not going to say, I'm not sure what I will say applies to Argentina, but in Europe, in many countries, engineering programs are actually 5-year programs. So actually now they are considered integrated master's programs. So in 5 years, for God's sakes, you do not need to ask the students to take, you know, 50 courses in engineering. You can build competence with 40 and let them take 10 courses, you know, from other departments. That's the kind of approach that I am thinking about, and that's what I meant.
Thank you very much.
¿Alguna otra pregunta?
Any further questions?
I see a question on Q&A, but I do not understand the second part. If the person who wrote it can explain to me what it means to make jack of all trades, master of none. Okay, so let me try. I mean, I don't see anything, so let me try to answer this. So it is true that the general trend in areas like in Europe, as I mentioned before, is to educate people in a super specialized manner. That is true. And then you build teams of specialists. That is true. So Mike, I have a question for this. So what happens, who's the one who's going to define the appropriate composure of the team of specialists to solve a specific problem? The person who's going to define this team actually is influenced by his own knowledge and his ability to understand what kind of specializations are necessary. But so he is the synthesizer, let's say. He is the one with the more liberal thinking. But if he's not, I don't know if the word liberal has excited the people, people here, but maybe I can use a different word. But what I mean here is that, if you have very specialized people, the people who are very specialized, they don't understand many things outside their specialization. And that's not very helpful because they don't get ideas. They don't define problems. If you want my opinion, and that's also a philosophical approach, if you like, is the following. I can find many millions of people around the world solving mathematical problems and very specific problems. To me, the most important thing is to ask the right question. And to ask the right question, it's not easy to do when you are very specialized. Most of the problems that are being solved and most of the contributions, the big contributions in society, are usually coming at the edge between disciplines and come from people who know different disciplines. Also, the way that I do my my supervising of my PhD students and so on, is that I try to teach them to ask their own right questions. To solve them, I don't want to, I can say that if I have a very difficult mathematical equation to solve and I can not solve it, I can guarantee you that I can find somebody who will solve it for me for $500. Okay, but the right question is where the value is, I think, because that's where the contribution comes and that's where the impact comes from. It's not from solving a Hermitian equation per se. It's a personal view, of course. I'm not asking for people to accept it, but that's my view. I think that's where the value add is coming. You're welcome.
Tenemos una pregunta más, ¿no?
We have another question coming in. Yeah, this is going to be the last question. Can we say that? I think that question has already been answered. So, okay. Professor Serpanos, it's already late in Greece, 7:30 p.m.
It's fine.
So, once again, I would like to thank you from the bottom of your heart, your selfless participation in this event, because you really contributed to the success of this project, of this event. So once again, we thank you wholeheartedly. We thank you for your presentation. And finally, to close this meeting, it's a huge pleasure to have organized this NEON Erasmus Plus project with an international scope, with panelists from Argentina and participants from Austria, Uruguay, with over 200 people enrolled. This meeting has been taped and has been recorded and is going to be available through YouTube. All the attendees will receive a link to access the recording. And we thank you for your participation. Thank you, Professor Tonello, who is the coordinator of the NEON project, and he's been a panelist. Professor Serpanos once again, and all the attendees and panelists, we thank you, and we are looking forward for upcoming activities. We have a lot of work to do, and once again, see you next time in the upcoming event. Thank you.
Thank you very much. Hello, everybody. Thank you.
Muchas gracias a todos.
Thank you.
Gracias, muchas gracias.
Yo te estoy escuchando en español. Sí, terminó el evento, todavía estamos, bueno, se están despidiendo varios. Sí, pero sí, ya lo damos por finalizado. Bueno, después en forma privada podemos hablar, Estela. Ya, si querés, lo podemos ir cortando las interpretaciones. Agradezco mucho tu trabajo